I'll pop up eventually. And then let's get this page. I need to move my car. Oh my God, go move your car. Yeah, no obligation. Do your thing. I'll be here. Look at this. I am here. Look at me. Pop out chat. There we go. Pop out chat. Bada bing. Deckard, my definition of chill. We've heard this one before. We're going to hear it again. Eventually, maybe, the modular synthesizer might take up the task of filling the airspace a little bit during intros, if I can get it to make things that are pleasing enough to my ear. Although how exacting and discerning is my ear, I don't know. You guys don't seem to be scared away by me choosing music for the intro, so maybe if something is pleasant to me, it will not scare you guys off. For right now, for this stream, all I have is speakers. We could maybe go the distance and try to wire into the mixer itself, and maybe I could position these speakers somewhere, or I could try to wire into the Focusrite 2i2. That's my other sound thing that I would like to be dedicated to the modular synthesizers that my friends bring over. This is the Engineer SS03. This is the best solder sucker on the market without fail. There's nothing comparing that I can figure compares to it. It has just the right distance so that if you have big thumb muscles like I do, I can seriously crush diamond with this fucking thumb after having done so much desoldering with the Engineer SS02. Why is this one the 03? I don't know. I don't know why this is the 03. It's the only one I could find. It's made in Japan and it uses the Star Trek TNG font on Engineer. That is the Star Trek TNG font. They made that in the 80s for Star Trek The Next Generation. You cannot convince me otherwise. That is definitely the Star Trek font. But this is the SS03 and I am not paid to say anything about it. This one, the advantage of this one is if you get 4mm inner diameter silicon rubber tubing, you can infinitely replace the tip of this one. Silicon rubber is such a high tolerance to heat that they use it in things like the soldering iron cable. This is silicon rubber. When you're soldering something with a wired soldering iron, you are going to often brush things like cables. There are soldering iron burns on some of these wires because these are all PVC jacketed, and PVC melts almost immediately at the glance of a soldering iron. So the silicon jacket allows it to withstand the heat of the soldering iron, and so if you have a pin on a PCB that you have to desolder, you can with the soldering iron in one hand, the Engineer SO3, I guess, in the other. Boom, loaded, soldering iron down. You cup the little rubbery end of this thing around what you're desoldering. Thump, lots of suction, and it'll take all that stuff into the barrel. Usually it doesn't make it all the way in. Usually it'll cool down right there, and then you push this all the way down, and it's got a little extractor pin. What happened to my Engineer SS02? I was cleaning it, and when I was cleaning it, because you can fully disassemble this thing, you can buy generic O-rings to go back in there. You can use dielectric grease, any kind of grease in there to help the piston move nice and clean and get all the little particles, all the little farticles of solder out of this thing. You can fully refurbish it, right? Clean the spring, clean everything, and it's good to go because it's a very simple device. It's just a piston and a plunger and a switch and a silicon rubber hose. So you can completely refurbish this thing, and I had been refurbishing mine since 2019 or something. The pin is long, and I bumped it, and so it was misaligned. And getting that thing realigned was such a pain in the butt, I figured I might as well get the SS03 and see how comparable it is to its predecessor, and it's exactly the same. They just coated it in slightly different colors. It's like exactly the same. I'm not certain about the tip here. I don't think they redesigned anything about the tip. So it's like literally the same thing. So yeah, anyway, this thing is the solder sucker to go to. The previous versions, like the previous types of solder suckers that I've tried have been like the Hako solder sucker. And that thing has a plastic tip. I don't know how they expect anybody to do any work with it. Plastic. And so if you touch it to what you're desoldering, the plastic melts and it ends up smelling like shit. It ends up releasing a bunch of particles into the air and you have to breathe that stuff in. absolute monster. But yeah, I had to buy a new one because I broke it this weekend working on this thing. The ADSR, I put in my own transistors, and then in the months that preceded doing that, I wound up getting the right transistors for it. So I used up a lot of the generic transistors that I had in order to, in a kit, this kit here, in order to put the proper ones onto this thing so it's a little bit less convoluted. This is an ADSR. It's attack, delay, sustain, R. I don't know what the last one is, but we're gonna try to get this working, because if I can get this working and I have the VCO already tuned using my tuner, we can move this stuff into the actual modular synthesizer case that I want it to be in. Release there, thank you. We can move it into the modular synthesizer case that I want it to be in, and we might have the whole audio path. I've got the MIDI input, I've got the VCO, I've got the ADSR, and then I have the thing to tune the output to the right voltage level so my speakers don't blow up. And that is the most basic form of synthesizer. We can then sort through the big pile of modules that I have and see if we've got a cool filter that we can put on things. See if we can get that far. We'll see. It's a challenge round. We'll see if everything is working the way it should. I'm not buying stuff. That's the big thing, is I'm not allowed to buy stuff. I've been buying my way out of a lot of these problems lately. And you know, with the general way things are, we're going to do magic hands for that. So doodle-doodle-doo. The way things are generally just in the world, I'm not in a position to pay huge premiums to just order stuff. So we're working with what I have, and I have a lot. I have a lot of stuff around here. There's a lot of things that we can, you know, harvest from and build from, and etc. This has been from multiple years of working with modular synthesizers and trying to build this. This is like the culmination of like 2 years of work. Even though I do have a lot more to show for it, and a lot of it was me learning all of the nuance of modular synthesis and what it takes to put one together and build, and the like low-level hardware that I had to learn. Yeah, there was a lot of that. We can credit a lot of that for the 2-year delay, but it's been too long and I haven't been able to make sounds yet. So enough is enough. And also, this is my happy place working on this stupid stuff. The Raspberry Pi stuff I have made some progress with. So what I'm trying to do is, I don't have the screen here, on a like 100 by like 130 by 64 or something like that pixel RGB LED display, I want to put up milk drop plugins. Milk drop plugins, if you know, this is a music nerd stream now, so you guys should definitely know Winamp. This is a music nerd stream, and back in my day, the early 2000s, we would sit around with milk drop plugins going, using our very limited graphics cards in order to create really cool, sort of layered, cool, trippy effects, right? Winamp, from a bygone era, everybody knows that it whips the llama's ass, but we would use it for visualizations of parties. Very cool. Milk Drop made some really cool looking stuff. Milk Drop uses OpenGL. And so in the years since Milk Drop, 20 of them, people have moved it to a more universal platform. And that work is not done yet, because I guess the programmers with their GitHubs and stuff like that, they get in there and they're all motivated and they make all this progress and they go, oh, okay, I'm done. And they can move on to another thing. It's happened to me with a couple people helping with this stream. They kind of move on to another thing, and then you're sort of the shepherd of the rest of the project. You have to learn what they did in order to incorporate it into your completed project, which they do not participate in. So Project M, I don't know if it fully suffered from that, but Project M is in a state where if you do the legwork of opening an OpenGL window, you can use it like use it like a library and control the Winamp plugins. VLC does this. VLC has those plugins in it, actually. I would like to use Project M in a Raspberry Pi. It has to be, it doesn't have to be, it could be a Pi 4, but it has to be one of the more recent Raspberry Pis, because the other one, I don't think the 3B Plus does OpenGL easily, and this is going out on a limb, so I don't want to have to deal with, like, oh, you have to use this thing and then that thing, and then this is a project in and of itself, but you can do it. I don't want to do that. I just want to, okay, OpenGL, Raspberry Pi 5, done. right? I can open a window in that. And if I can do that, it's possible that I can write a little C++ to output the pixels onto that RGB screen. The reason I want to do that is because the pixels are far apart. And I have experience, I've done this before, where you have LED strips and the pixels are really far apart. But if you use something that makes a coherent visualization, and you have to pick and choose which of the plugins you want to use that people make. I would like to use the ones that use OpenGL, but I need it to be a very simple color space and I need bold things moving around. You can make those LEDs intelligently make a kind of visualizer. It's not really like the visualizer that you see with all the pixels on the monitor, right? It's like looking through a grating at that. But it really does do a good job of making fascinating looking visuals out of your LEDs. And then it's not just an RGB train. It does, you know, oranges and reds and things flow and shapes move around, and, you know, your human brain makes patterns out of it all. It's very, very cool. And then we can make it react to music. But mainly what I'm doing there is, one, getting familiar with the Raspberry Pis again. Two, getting a cool looking visualizer on the front of Burn the Subs. And then from there, it's justifying the horsepower of Burn the Subs. Why am I doing this with the Raspberry Pi? Because, you know, yeah. So we can then get into the visualization with that sort of plugin thing and get Project M working on the Pi as sort of its own standalone thing. That way, during the day, when I'm not streaming, Burn the Subs is using some power, so the power supply doesn't end up screeching. I guess it doesn't really, we kind of turned it on, it didn't really make any screeching noises. I don't know why mine did. Using the same power supply technology, mine would screech when it didn't have enough of a load on it. I don't know if it's got something for that, but, you know, utilizing that super duper nice power supply in order to light up some LEDs should be pretty cool. And then hopefully Clipper has enough resources to kind of run on its own. If it doesn't, we could maybe use GRBL in the actual motor controller. We might end up using that Gerbil update. It was like Gerbil EX or something like that. I forget what it was called. But if we use Gerbil, then that's all on the controller for the board. And so the Pi will just be responsible for sending G-code over. So maybe that's the way to go. Raspberry Pi might be OpenGL ES. Yeah, that's the one that I was just looking at. I found some kid did a tutorial and it uses Visual C++, and they were doing it for just like desktop OpenGL environment, which I should probably do first. I should probably follow that tutorial first because it's not specific for the Raspberry Pi, and putting that onto a headless Raspberry Pi, I don't know what that's going to take. I don't want a desktop environment on the Pi. The Pi needs to be headless and remote, right? And especially for this thing, if I decide to deploy the same project with LED strips, like on my wall or for a festival or something like that, I want it to be its own little standalone, like here's this thing, and you hook this up to a bunch of LED strips, you tell it what you're doing, and then it'll light them up with, you know, super nice plugins. I kind of want that because it would be fun to put some LED strips on these walls and make them do stuff. But yeah, OpenGL ES, headless, don't know how that's going to work. I think maybe I have to figure out how to make a full resolution window that isn't like a desktop window. It's not using like the KDE or whatever Raspbian like window API. I don't need that. I just need to be full screen basically. I think that's possible. I haven't looked it up fully yet. I've got some tutorials. There are some examples on OpenGL ES's website that I'll check out. But yeah, that's the idea. So I can get Project M running, then we can put our G-code creator, maybe not on the Pi. I might actually move that to the file server with Node-RED, because then we can just have a very light program that will sit there and be a like a WebSocket, and we'll just send over the G-code that we make for it. Maybe. We could do that. We could put Burn the Subs back so that that whole thing is doing it, and then from Node-RED, we just give it the screen name, like the username, and it'll just place it on the board. Maybe that's the way we should do it. Should be able to kill the desktop environment service and start just the X server by itself using Startix. Okay. I'm not fully versed in, yeah, that's something to figure out. And again, thank you, BasePath, because I don't have streams like I wanted to do today, which would involve OpenGL EX on the Raspberry Pi. those are entirely dependent on there being experts in the chat, because I will run into something and I won't be able to answer it for myself, and I'll need the goading or the frustration of chat to kick in and actually feed me some kind of a path to an answer. Although following the kids tutorial that I found on YouTube is probably the best way for me to go, because then I can open it up on a Windows desktop environment and say, okay, there's OpenGL. I know I can get that working with this stuff. Now let's move over to the Pi. Got to break it into little nibbles of project. And I probably could have done all of that last night if I was brave. I'm not brave. Do I even have Visual C++? Hold on, Visual. I have Visual Studio. That's not, I could do a Visual Studio C++ project, right? That's possible. There was just a lot of weird stuff with paths that you have to resolve, and the tutorial went way into the weeds. It was a very quick talking tutorial, which I love, but it also got into some weird stuff, some weird setup with Visual Studio or Visual C++. I forget which one it is. I gotta watch it again. I gotta like memorize it. So I spent part of my weekend doing this thing. It was actually happened a lot quicker than I think I realized it would. This is the ADSR, what is it again? Randy and Bill send their love. This is a fully analog ADSR from Linear Circuits. There it is, ADSR 312, right? Very simple circuit, very easy to put together. It's an ADSR. It's kind of like a filter. It's not really. It's sort of more like controlling how your notes come out of the VCO, because the VCO doesn't do volume control. It's always just beep, bop, 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 you know, whatever. So if you want those to be succinct notes, actually it's not beep, bop, bop. It's da, 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 da. It's a constant thing. Or rather, I was doing duh, and that duh is what this thing creates. So this alters the volume of the tones that are coming out of the VCO. And that makes it feel more like an actual piece of musical circuitry. It makes it feel more like notes that are being played on something like a piano, which is kind of famous for its ability to damp the keys that are the strings that are being played by the keys. So I originally put this together with my own transistors. This guy made his own transistors? No. These are generic. The 2A is generic, sort of 2N2222, I believe. I think, or 3904. I forget which one it is. They all have slightly different specs, and I have trouble substituting transistors for transistors. And also, the pinout of these little transistors is insane, and it's not all that readily compatible with its TO. That's not TO22. This is whatever the hell these things are, the big D-shaped things. Not all that compatible. And I had a bunch of wires on here that were sort of converting it over. So what I did is I desoldered all the surface mount transistors, and I broke my Engineer SO2 solder sucker, SSO2. It's a solder sucker. Well, it's, yeah, anyway, Engineer. And so I had to order this one, and then I cleaned up the whole board, and I put the correct transistors on this thing, the British BC, what is it? 547 and 557s. These are what were called for by the original schematic. So we'll have to see. Wait, X server is DirectX server? Interesting. Yeah, I know it's like a perfectly possible thing to do. And then in the C code, what I'll have to do is grab individual pixels, put them into a matrix, and send it away. Stiff upper lips. Yes, they have a bit of an accent, but it's generally tolerable. Yeah, no, these apparently the BCs are the British ones. I don't know. I burnt my finger on the friggin' toaster oven. We had a little toaster oven, and I was putting cheese on something, and it's right onto the burner. So I got this big nasty wound at the top of my finger. Hopefully it won't be too prominent in the cameras. What's up, Pseudomaze? How we doing? I know I haven't been around this week. Things have been kind of crazy. Crazy all the time. Oh, I gotta get into Streamlabs. Stay up to date. No. Log in with Twitch. That is a big man that they have on that. All right, come on. Let's go, let's go. Yeah, I had a lot of sorting of prescriptions this week. There was a lot. I'm almost done with it, though. I had to play phone tag with pharmacies quite a bit. I think I got all my titles set up. I've got all the imagery set up. I've got the thumbnail set up. I have the fan on me. The dogs are, all the corgis in the neighborhood are upstairs playing together. And then I know I should have a camera on that, but it's not as exciting as it sounds. They usually just sit around each other and bark at stuff occasionally. And yes, I know even that should probably get its own camera. Maybe one day it will. But that means that Willow is busy, so she's going to be tired this afternoon and quiet. Tired is quiet. Been trying to work on a project of my own, collecting salvaged parts to build it. I need a 7812 in the SMD format and can't find even a TO220. My experience is that it is extremely uncommon and you almost never see one. I can't remember the last time that I ran into a 7812. In a modular synthesizer environment, you might actually find it in the power supply, although I don't like it versus the like PCB power supplies that can supply much cleaner power. They're more complicated. They've got more circuitry in it. They've got more ASIC style stuff to make sure that your voltage levels are nice and good and clean. 7812 is like a fairly simple beast. It will convert all of that extra voltage you put into it into heat, which is fine in a lot of projects, but you know, you may have to put a heatsink on it. That's why I don't like those. But 7812, I almost never see them. You see them in modular synthesizer power supplies, because again, you've got 15 volts coming in, and turning that into 12 is important, and that'll do the job for you on that. Where else would we find one? A car electronics, maybe? I saw some, yeah, many in audio equipment, yeah, because they need plus minus 12 volts. Even, you know, the motherboards, maybe if you've got derelict computer power supplies, maybe you could find one there, because they have to make negative 12 volts. I don't know. The primary 12 volts, they're not, in a computer power supply, they're not going to rely on voltage converter chips. They're going to be much higher power, like MOSFET driving chips. They'll still be voltage conversion, but still it'll be like FET based, because then you can put whatever. Flatulent Gonad gave you a shout out to 100 viewers 4 days ago. I think I remember. Do I remember that? It was 4 days, I guess. It's been a hell of a week this year. 4 days ago would bring us to Tuesday. Tuesday. So that was when I missed the first stream of the week, and then I missed the second stream of the week, because things were crazy. What else has been going on? Nothing I can talk about, unfortunately. The shuffle with prescriptions is something that happens every now and then, but I've mostly got them all. I just need to do a Caremark order for pumps, and hopefully nothing goes wrong with that. Eventually the state's going to catch on and be like, why are you so expensive? And they'll be like, because I don't want to die. I have a transformer with two 6-volt taps. I'm going to combine them, make 12 volts for a tiny 30mm cooling fan, and use one to make 6 volts for 5-volt DC. Oh my god. Okay, so 6 volts into a capacitor and a couple diodes, and you've got 5-volt DC. Clean 5 volts DC. Clean-ish. You could probably also just throw it into a 7805 or something with a big cap. 2 6 volts to make 12. That's going to be a strained 12 volts. I mean, I guess that gets there, though. Yeah, we don't have any shenanigans like that going around in the synth. The synth is luckily just, here's 15 volts, make 5 out of it. And for that, I actually have on USB-C here, I have a 15-volt board. So it'll negotiate, make 15 volts. And then from there, I've got my positive 12 and negative 12 power supplies, as well as a 5-volt, even though that's not strictly necessary. Not a lot of, I haven't run into any modules that use 5 volts natively from the power supply. All of them are putting 7805s on the 12-volt lines. Pretty much plus minus 12 volts is all you really need for modular synths. You have to pull in some weird or old equipment to need 5. I have it because we encounter weird equipment here. We encounter it all the time, so there's a possibility that I would need it. We're going to try to put things into the main rack, though. I think that'll be fun. I think we'll actually be able to make something that's able to make musical sounds from the keyboard. What I wonder is, will the tiny fan not care about 12.6 rectified, which increases the voltage 1.4 times? 0.4 is a lot. That's a lot. So around 14 volts. Will 14 volts burn up the fan? Might not. It might not. In my experience, at least, I don't know about tiny ones, but the little boxy computer fans, they will get very hot if you go over 12 volts, but they will tolerate it. You could be prematurely blowing up the fan. The fan will certainly put up a fuss. It's possible to put like a current limiting resistor on it, like they do with the Noctua fans. They have their speed reducers that are literally just a like 1 watt resistor sitting on the positive line. Yeah, putting a 7812 on it will certainly make the fan be less ready to meet its maker. It'll put it in less of a position, and it won't be overdriven and sound like it's going to explode. They will tolerate it. It might not break at first. I've gotten up to pretty high voltages with those brushless DC fans. But yeah, it's not 14 volts. Not great for one. Not great for one. So finding a 7812 is, yeah, that's the bluntest way to do it. Do you have like 14 diodes that you could put on there? The voltage drop of each being 0.7. So 14, 13, 12, you've got 2 volts. You're going to need, I don't know, like 4 diodes. Like 4 diodes to drop it down. Yeah. Because you're dropping 2 volts. So you're going to need 4. Just estimating. 7 and 7 is 14. It's not unheard of. I've seen it before. I've seen the diode voltage regulator in action. Your voltage, you're wasting all that power across your diodes, 0.7 at a time. Yeah, so this is Linear Circuits CEM3340. The CEM3340 is a chip. It's an ASIC that is basically a VCO in a modular synthesizer. It's got all the right stuff in it, not by accident. It was literally purpose-built in order to be a modular synthesizer chip. And so nonlinear circuits went, let's make something with it. And so they did. And I bought the PCB of just one of these things, and it's got a lot of cool stuff going into it. You can do a lot with this, but it is a more traditional analog style modular synthesizer thing. I've got some modules that are very digital, some modules that are very analog. It might be interesting to set up my synthesizer because I have 2 of the cases. So if I set one up to be digital and the other one to be analog, I don't know. It's a thought. And then the other thing that I might want to do is take the piano that we have. We have it's more of a keyboard than anything else, but it is set up to have weighted keys that feel like piano keys. And if I set that up with MIDI, I could send it into the 2 cases and possibly mount the 2 cases at the top of the keyboard. So I'd have a big keyboard, a big spread keyboard, and then 2 cases on top. I don't know if it splits up the MIDI though. I don't know if it might be too old to do that. It does have MIDI output, and I think I can split the keyboard. So that might be the way to do it. If you do individual notes on both things, you can control individual, 2 different banks with this MIDI thing that we built. And I've mostly tested this. I don't really know what the bottom of these, I don't know what these do. We'll have to look it up when we insert it into the rack. But I had to reverse the LEDs to get those working again. So now all the LEDs work and they light up the way they should. I think this one, I'm not totally sure about this one. I think this one might have to do with the tempo, which I haven't tested yet. So I don't know if that one's incorrectly. I do see the yellow LEDs light up and I do see the MIDI LED light up. I haven't tested this with 2 banks versus 1 bank because our stupid M audio thing, which is, boy, that's just the default M audio. This is M audio, right? Oxygen B? Yeah, I think so. Usually it's like, well, I bought this M audio thing and it was cheap and it kind of works and that's it. That's been my experience with M audio. I don't know if somebody can correct me on that. There goes the dog barking. Considered making a shunt regulator with a few Zeners. Those work too in a pinch. I don't have much experience with that. Do those get very hot? Do the shunt regulators using Zeners get very hot? I've seen them in application before though. Yeah, they're definitely a viable thing. Honestly, I just like look through the couch cushions and find a 7812 or something linear or low dropout rather. How much? Okay, I know Amazon's probably, I don't know where you're from actually, if Amazon is viable, but yeah, $6 is not terrible if you've already got Prime. Or you could get Brojack. Oh, Bojack, sorry. Sorry. Single channel mind here. For $13. But I have a lot of international viewers, and I know Amazon's not viable for a lot of people. But yeah. It's better, it's probably more efficient than 12 diodes. Let's see. So I did a little bit of work on this tuner over the break as well, because I had to make it output the proper voltage per note that I was tuning to. And I guess I'll wait and I'll talk about all that. We'll talk. It's going to be a long talk because there's a lot of setup to do, and I want to bring you guys along the journey with me. And then next stream, I think on Saturday, I promised Short Lurker that I'd work on my car. I said, Short Lurker, if you fix this thing that's wrong on your car, I will fix my windshield wipers for the first time in like a year. It's been a year without 2 functioning windshield wipers. The driver's side works. I am unfortunately adept. I am particularly skillful about avoiding fixing stuff on my car. And so having a driver's side windshield wiper was enough. And I'm not driving all that much these days. I like go to the market. That's about all I do. And take Willow to the vet and stuff. I remember seeing somebody who bought some Bojack MOSFETs, and they were literally just leads stuck into a plastic package with no silicon. That seems to happen to other people a lot more than it happens to me. I've had one instance of that happening where we got a chip and it just wasn't the chip that we got because I bought it on like AliExpress or something like that. It just wasn't the right chip, but it was labeled as such. So it was, because there's a lot of fraud in the electronics world apparently now where they just relabel something that was junk. SparkFun famously ran into this with Atmega 328Ps that they bought overseas. They were shipped in, and apparently they've identified what the chip is that they were throwing away because it did have silicon in it. It was actually connected, and you did get diode voltages by probing the pins. But they made a joke data sheet where it was a Atmega 328P slug, and it said NC for every single pin around the chip. And it was very funny. You got a sensible chuckle if you were a... oops, I hit BRB by accident. You got a sensible chuckle if you were a skilled electrical engineer and you could get jokes like that. And they were selling them. You could buy them. And so somebody bought it and they decapped it and they actually figured out what chip it was. Some ASIC, I think. I don't remember exactly what it was, but that was a whole thing. That was in like 2015 or something, maybe earlier. But I've not really run into that sort of black market weirdness where you get something that's just not what it is. We had that happen once, and it took a lot of testing to get there. It's very frustrating. But yeah, the kits that I get on Amazon are generally okay. We are a niche, of course. We're a total niche, so you don't exactly get reviews of these products because nobody's ever bought them. Sometimes you're the first person to buy it. Every now and then, though, the stuff that percolates to the front, you can see there's a couple reviews, so you can take a look at that, and if it's reputable, I usually just buy. I usually just buy because if I do happen to get scammed like that, it's funny, and we have a big story that I can tell. But for your purposes, the royal you, as in the people watching, you might want to like find something that's been reviewed a little bit. Or maybe a reputable. I don't know what's reputable anymore, though. We'll start in just a couple minutes here. We got plenty of stuff to do. I don't know where I'm going to put the case that these will populate into. Like the little modular tester is perfect for this desk because it's framed nicely and it's got this nice angle to it. And it's all beautiful. But then the cases that I have are enormous, and of course the stack that I'm trying to build in the synthesizer won't fit into this thing, so. This thing has been great. I retuned it. So that it has the proper note per volt. Oh my God. Motion detected at the front door and all the dogs go absolutely psycho. What was I sending the sine to? The sine wave to, or whatever this was. This is, oh, high-low. Yeah, this is supposed to be for the ADSR. High-low and low-high, very low hertz. And then the center button does C4 is 4 volts, C6 is 6 volts, C2 is 2 volts. So I jump between these and try to tune up the synthesizer so that it has all the right voltages on it. And you have to bounce between basically what is slope and offset. So one of these is slope, and there's another one right behind this knob. You guys can't see. Slope and offset are these two. This one is a scientific potentiometer. It's got 25 turns on a stable worm gear. For some friggin' reason, this one is a surface mount potentiometer, which makes it extremely frustrating to adjust. I don't care if the 25 turn potentiometer is on the sort of more coarse adjustment, because when it gets down to brass tacks, when I get really close to the note, I need that subtlety. With this thing, what you do is you put the spinny-majig, the screwdriver, onto the potentiometer, and that changes the value coming out of it because of the microscopic change in position from you just seating the screwdriver onto that spinny bit. And then I put just a little bit of pressure into it, and it'll totally change the waveform like an astounding degree. So a little word to the wise on the design. Put scientific potentiometers on both of your adjustments for something like a VCO. It's much, much easier to control. And I don't know if I can glue something onto this or replace it and put a nice 25 turn on there, because I want this thing to be like locked in. I want it to be super locked in. I don't want it to sound a little bit sour if it gets to certain notes. The problem is I was adjusting the two extremes, and I got the two extremes to line up perfectly, but then the note in the middle wouldn't. And by line up perfectly, I mean there were no beats. When you're tuning something, if you are a particularly skilled musician, you are counting beats. You are listening to where the two waveforms interact with one another, and if it sounds like it's getting quieter and louder at a certain rate, if it's a fast rate, you need to tune a little bit more closely to the waveform, and if it's a slow rate, you're getting really close to matching the two. When they harmonize together and they enhance one another properly, you don't hear those beats. Those beats are where the slight misalignment of frequencies causes the two waveforms to cancel each other out. And it's something you can hear. If you listen to enough, you can hear it. DigiKey Mouser, but even those have people committing fraud. Yeah, because they're going directly to the supplier sometimes. When they buy 1,000 chips, swap them for fakes and return them. Ugh. I hate that there's that much fraud in the electronics industry. It's just something we gotta like deal with. Luckily though, I've been relatively sheltered from that sort of thing. You know, sometimes every now and then you're like, oh, well, that was a fraud. Whoops, move on. It's only $5, you hope. I gotta find a better method for labeling these things. The little heat press that I could use to label all the different ins and outs is like $75. It's a little bit expensive. I was unable to get the printer to print like coherent labels. That's easy to do in #AutoCAD add. Maybe I'll do #AutoCAD add and we swap the nozzle on the printer for the smaller one. And we'll set that up in Clipper, and then I can see if I can actually print with labels, because that would be really useful for the Sharpie method not really sticking to PETG. As I plug things in and unplug them, my fingers are like barely touching these, and so all of my markings have worn away. And I have to pull up a picture of the front panel on Google. With the smaller nozzle, it's possible that I can have much smaller text sort of engraved into these panels. I like having the 3D printed panels. I like it. It gives me a coherent look to everything. It may not be the best way to do things, but it is a way to do things. What up, Brink Gigi? Gigi. Sorry, I'm burping a little bit. I had a chicken Caesar. No, it was a Chipotle wrap, actually. I thought it was chicken Caesar. and I took a bite and was pleasantly surprised that they put chipotle sauce on it, which it's a wrap, still has carbs, still has fat in it. It is one of the least fatty options though. Hopefully I'm not burping off stream. I apologize for that. The Ozempic is going well. My glucose levels are down. They're more controllable. I had a blowout last night. I don't know what it was. I had meatloaf, leftover meatloaf, and maybe that's what triggered it. Probably all the fat in the meatloaf. My glucose level went straight to 300 and it stayed there from 6 o'clock-ish when I had dinner all the way to 10 p.m. Meanwhile, every couple of hours, I was giving myself a large bolus, like 10 units, and it just stuck at 300, which is weird because you would think if it was the what I ate, the amount of carbs and what I ate acting, it would keep going up, or every time I bolused 10 units, it would drop down a little bit. Nothing like that. It's stuck at 300. I think this is my liver fucking with me. I think because the liver can do weird stuff. I don't know if this is a fully blame the liver thing or if I triggered something by eating that much fat or volume. Something wasn't clicking last night. Exercise might have helped. I did take the dog for a walk after dinner. It may not have been enough of a walk. I didn't know my glucose level was going to spike like that. So it's stuck at 300 for hours and hours and hours. I'm just giving insulin, giving insulin, giving insulin. Finally at 10 p.m., it started to go down. And at that point, I'm going, how much latent insulin do I have in my system? Like, is this going to super peak on me? The Android Auto Pancreas system, of course, was watching out for me the whole time. So unless I had enough to spike super low, I would have been relatively safe. And it did end up just going down to normal and then tapering in normal land until I ate lunch. What's it doing right now? Are we still super sensitive? No, we're kind of climbing a little bit. Here, let's, where is that? I might go hyperglycemic. I may have to go get some water to make piss. Can't talk right now. I'm making piss. I love that meme so much. Yeah, see, we're at the top of my range. I'm old school from the 90s with diabetes, and I try to stay within 80 to 180. Other diabetics will have tighter ranges on that. I do 80 to 180. That's generally where I try to be. And then this spike, I don't know what that was for, but this coming all the way here at the end, that's lunch. What the? Last Miles rating with a party of 73. 73? That's like a million people. How you doing, Last Miles? We're gonna tune some synthesizers today because it's my my happy place. Shoot. Huh? Yeah, so we're gonna tune some synthesizers that I built. I'm just talking about my level here ahead of stream. We chew the fat a little bit. Speaking of chewing fat, I was 300 basically the entire night last night, possibly due to fat. Leftover meatloaf may have done this to me. It was very weird though. It's like I was possessed. My glucose levels were possessed. They just hung at 300 while I gave copious amounts of insulin. Let me move BG out of the way of chat. Where's that? Frame blood glucose. There we go. Gotta click on it. We'll just put it over the side of my head as if it's haunting me. I need to raid my fridge. Go eat. Yeah, you've been streaming for 1 million hours and you have 10,000 people falling onto my stream. Welcome to my shop. If anybody's never been here before, Last Miles frequently raids, and I need to check to see if Last Miles is ever streaming when I end my stream, because I should return the favor. So many geeks, yeah. One time we raided Djibouti Show, who does gaming content, and they're like a bunch of crazy guys and they do cool stuff. We raided Djibouti Show and they were like, what should we call your viewers? And I'm just like, nerds. There's no pretense here. We're a bunch of nerds. I'm part of the raid, but I'm here all the time anyway. Yeah. There's a lot of overlap in these channels and I love it. If you guys have a chance, follow Flatulent Gonad. My people who are here who don't know Last Miles, you should. Last Miles does quite a good stream and raids every now and then. I don't know how many people, I don't know how many people think I should raid them or not. I don't know. Nerds or geeks will do. Yeah, that'll do. So anyway, my blood glucose level, the reason that you guys can see it here is because I have a Dexcom G6 and they will peel the G6 from my cold dead hands. I'm going to use that Dexcom until I can't, until they do not allow me to. The G7 has a lot of stuff built into it, which is sort of a single use only thing that they do with these diabetes supplies. And they do it for a very sort of watery reason. It doesn't really hold that much water. The reason they do it is because the body will reject this stuff after a certain amount of time. But if your body doesn't reject the stuff after a certain amount of time, they'll reject it for you and not allow you to use this equipment in perpetuity. So Dexcom G6 is a Bluetooth low energy device. There were basically begging and pleading with Congress that we need to do research on diabetes, and we can't do it if you guys are encrypting all of your signals. Bluetooth low energy has a very large amount of its structure dedicated to medical device and medical electronics. And a big portion of that is diabetic devices. So there's an entire chapter about constant glucose monitors. There's an entire chapter about insulin pumps. So I have what's called the Omnipod, which is a little white plastic pod, roughly this shape. These are the internals of one, not exactly functioning or together. We should probably take apart another one at some point. I have a little adhesive pod that's sitting on my body with a plastic tube that goes under the skin. I also have a little patch on my shoulder that has a bimetallic tube that goes under the skin. The interstitial fluid can be measured in order to determine what your glucose level is 5 minutes ago. So it takes a little while. It's got to soak in the stuff and figure out what's going on. And that they have been able to get the Bluetooth low energy signal and have a third-party application, which is this, it's called Xstrip, read those glucose levels. So I don't need to use the Dexcom app. The problem with the Dexcom app is that it sucks. It makes you lock your phone down and do all this other just heinous bullshit because your phone is kind of becoming a medical device. But those of us who know how to use stuff at a little bit more of an advanced level, Xstrip is the way to go, because I have been able to tie this thing into a Heroku app. Heroku app lets you run an app on like the public internet from their server, and you get a little database with that that you have to pay $5 for the amount of data that's being stored. This stores all of my bolusing information and my glucose information, and you guys can just go to CGM Databot. I didn't know I was signing up for something that was specifically for me. I thought I was just naming a generic app. I should have called it like Jesse Heroku app or something, but I called it cgmdatabot.herokuapp.com. You just go to that website, boom, there you are. You can see all my glucose information. You can't control anything without a big key, a big alphanumerical key. So I reject your device. Wait, I reject your device if your body does not. Yeah, that's what it does. It locks you out. So yeah, there's my glucose level for the public to see. My phone is using this information with an app that I had to compile in order to manage my diabetes. So while I'm streaming to you guys, I don't have to think about what, how many units are in my system right now. What am I doing? What am I bolusing? This thing will handle it. And if things go out of control, it will bring me back into the realm of decent glucose control. What did they change with version 7 of which? Oh, the G6 to the G7. It's like a totally different piece of, it's the same stuff, but they put it all on one adhesive patch. So it's this little circular patch with a hole in the middle for the auto injector. And that puts the bimetallic wire beneath your skin, but the transmitter and the sensor is the patch that holds the little piece of wire. Those are one thing. So in 10 days, that whole thing expires and goes in the garbage. It's pretty obnoxious. My only concern is, why would the presentation layer require a key for control? Well, because if you want to, I think this can do a little bit more. I think can Xstrip control stuff? I don't know. It's to like permanently change the visualization that's going on. Like you can temporarily change your visualization for your own session looking at my glucose levels, but I'm the one who gets to control what information goes on there. Yeah, without the API key, everything's just read-only on the site. So it's moderately okay that I'm letting everybody know where my database is. All right. I kind of want to get started. My glucose level is teetering on the line. It has not been it gave me a little microbolus of 1. I think it's still riding the insulin. Why isn't it displaying the insulin on board? There should be, well, it is displaying the bolusing, but I don't know, there's another view where you have like up and down arrows on it. I'll have to work on that at some point. All right, so high glucose level, man. Oh, I don't have a control for that on here. I have to manually click on the thing. BG. The mix has changed already. It's no longer a chill mix. It's gotten very unchill. I'm gonna just fade it out. Okay, I just paused it. Those on YouTube, if nobody's really watching on YouTube, but if anybody's watching on YouTube, you can't hear the audio because YouTube is a dictatorship where they don't allow you to play music. Because people have copyrighted audio frequencies of every kind. Almost every song will get you dinged. So on Twitch, we have a separate track that we're able to send the audio to. So if you're watching live, you hear the intro music. That's all you get for watching live. That and the ability to interact with the streamer. But you can hear that music, and so it doesn't sound so schizophrenic when I start bleeding out music lyrics. On YouTube, you will not hear that. And on the VOD, you will not hear that because, again, copyright robots are going around decapitating all of us if we slip up even a little bit. If we play radio static, we're going to get got. So that's the deal with that. I explain that every time. I know that's kind of tedious, but whatever. I need to explain myself because someday somebody's going to be watching YouTube or some AI is going to be scraping my YouTube videos and go, why is he bleeding like a weirdo? And then, 10,000 years in the future, some AI-powered robot is going to like twitch at one point because it got my bleeding from my stream and it didn't have context for it somewhere deep within its algorithmic brain. Okay, anyway, we'll be all dead and dirt by then. Here is my part of my modular synthesizer. I have not, in the, 2 years that it's probably more than 2 years that I'm not, it's kind of a little bit disheartening how long it's been. In the years since creating this synthesizer, these synthesizer modules, I have not been able to make anything that sort of resembles a coherent modular synthesizer. That would be nice. No, that would be not our concern. Yeah, no, probably not exactly my business. Okay, so anyway, modular synthesizer. We've come a long way. I've got an entire bin that's filled with modules. And I've got modules like all over the desk over here. And then I've got the case for the modules sitting right at my feet. You can't see it. None of this has gone together to make a coherent synthesizer. And I still don't know what the hell I'm doing. Certain things are necessary to make an synthesizer. Recently, we built this MIDI output. And this MIDI output has two sort of important things that it lets out, that it bleats out of itself. It will let out a 1 note per volt signal. It will also let out a velocity signal. So if I hit that thing harder, if I hit the button harder, it'll make a little bit more voltage. That's kind of cool. What do you do with that? Well, you don't do anything. You can't do anything with that. That doesn't make any sound. And I also have control of how the change of notes, how quickly the change of notes occurs. Look, we tune this. We put a lot of work into tuning this. I had to sit there and hit a button on the keyboard to move a millivolt signal to be within specifications. A lot of trouble going into this thing just to make this like it's synthesizing. Synthesizer, you think of the thing with the orange keyboard thing with a bunch of controls up above. Well, what that synthesizer contains is something that will make voltages per note. It has something that will convert those voltages per note into note. It then has a thing that moderates the notes so that they're not just instead they're beep, burp, bop, right? And then it has some kind of a filter, some kind of a cool futuristic sounding filter on that audio that's coming out of it. And then ways to control all of that. And there are also ways that you can automate the control of all of that. That's what modular synthesizers are. So this thing right here being a digital tuning interface is a way to control those signals without having to sit there and flip knobs all the time. So that's sort of the gist of a modular synthesizer. From there are different philosophies going into the modular synthesizer. Do you do everything digitally? Do you do everything analog? Do you want the modular synthesizer to completely control what it's playing without your input? Do you want to have MIDI input from like a keyboard so that you can play the synthesizer? Or do you want it to dictate its own thing? So you plug that in. It is a walled garden. You're plugging all these signals into each other. Oh no, this audio signal went into a control signal. Wait, but the output was good. That's the kind of thing that you can run into with a modular synthesizer. There are a lot of modular synthesizer people that are really not able to explain what I just explained to you in a succinct fashion. Now, all of those signals have different specifications. They've got different voltages around them. If you're triggering something like a drum bit or, I don't know, a filter, something like that, you have a 0 to, I believe it's like 5 or 8 volt signal. If you have audio, it can be 12, well, it can be 5 volts, it can be 10 volts, it can be 1.5, it can be all over the place. Anything goes, right? It depends on who's designing the different modules. I have been privy to a lot of these voltages because I'm coming into this system from the standpoint of an electrical engineer, not from the standpoint of a musician. You know, you have various control signals that can get up to 8 volts or plus minus 5 volts. You have a number line, you have a positive voltage and a negative voltage. What is that bother? What is a negative voltage? What does that even mean? I mean, I know you can see, if you look at the electrons are flowing in one direction, now they're flowing in the other direction. Well, that's one way to explain it. Another way to explain it is that negative voltage is just a re-reference. It's the potential difference between 2 points. So you measure at one point, you measure for another point, and you can see that there's 12 volts difference from there. There's 12 volts difference from there. We're calling this negative because this is technically 0 volts at the bottom, 12 volts at 0, and then 24 volts up top. You could change the number line like that and say, well, it uses a 0 to 24 volt signal with an offset of 12 volts. Instead of doing that, we're just defining that middle piece as 0 volts. And so all the operational amplifiers, the mathematical transistor circuits that determine a transfer function for voltage in versus voltage out, those we'll just say are plus minus 12 volts. That eases up our math a little bit, and we can, you know, play with the circuits a little better that way. It just makes things just a tiny bit easier. So hopefully that's not in one ear, out the other. I think I'm explaining that okay. I'm not sure. Or it's one of those things where the second you take a step out the door, all of it just leaks out of your brain. So I have been working on tuning stuff with this. By tuning, I mean when you plug in a note per volt into this device, you have a fine tune and a coarse tune. Those don't matter if everything else is completely weird. If your difference between notes and volts, the number line is off by a weird slope or some other thing, you're going to get weird results from your note per volt, especially if you're trying to like arpeggiate or make things that sound pleasant and in relation to one another. If you're trying to hit musical notes together that have relationships with each other that are known by musicians that don't sound like shit, you need to have some consistency in there. And when I talk about adjusting these things so scientifically, I always get a little bit of pushback from the real modular synthesizer heads who say, well, you know, I mean, this thing is kind of like, some people say the modular synthesizer is a life of its own, and that the tuning and stuff is sort of its own. No. That's you're not talking from an engineering standpoint. You're talking from the privilege of working within the walled garden. We're outside of the walled garden. We're making sure there's enough space in the walled garden for you to work. That's the thing. So you can feel so free about tuning your synthesizer. We need to actually really grind our axe against this thing and make sure that everything is ready to go. So I have these two controls on the oscillator that will do the slope and the offset of the note per volt. But then on top of that, oops, hold on, that's the wrong one. Nobody can agree on what note per C note octave is acceptable. The note per volt, or sorry, keep saying note per volt, octave per volt. It's an octave per volt, right? Each volt is an octave. Each volt represents a different octave. So if you are on the square volt, like 0 volts, like 1 volt, like 2 volts, you are on the C note. Because typically you tune using a C note. C note's the middle of the piano. C4, I believe, is the middle. It's the one that we're all familiar with. I think I flirt with perfect pitch. I get close, but that one was off by a lot. We'll have to see when we actually start hearing notes out of this thing if I think I'm in the right spot. Maybe I'll have to get a tuning app. I was taught by the Yamaha synth people that the key concepts are attack, sustain, release, decay. That's ADSR. That is what this module does. That's what this module does. This module is ADSR. That is one component in the grand scheme of the synthesizer. But it is an important component, and I just did a big revision on this thing. So that's what we're going to get at in a minute here. But so one note per octave, right? Each note in that octave, because, you know, octave is split up into a bunch of succinct notes. And if you really want to get out of that system, you can. You can tune above and below that system. You can sort of slide around that system and do weird stuff. But generally, when we're talking about musical notes, we're talking about A, B, C, D, E, F, right? G. So do, re, mi, fa, sol, la, ti. And so, you know, do, which one is C note? Is it re? No. It might be do. I don't know. Anyway, C note, we put on the square volts. Each note in succession is something like 0.88 volts from the other ones. What did they say up here? Did they do the calculation? Used for when concert A, 440 hertz is above middle C, 261.6. If your modules prefer a different voltage, blah, blah, blah. It's something like 0.88 of a volt per note, right? What's that? Attack 0 milliseconds with the decay 0 milliseconds, release 0 milliseconds with the decay of 2.27 milliseconds is a square wave at 440 hertz. Huh. During this era of what? See my Farlight. Using those four and a bit of noise, you can make a sine wave sound almost like an instrument. Yeah, it's kind of incredible, and that's where the synthesis comes in. You're synthesizing an actual instrument. Using something to create a volt per note signal, something to create that attack triggering signal, a voltage controlled oscillator, an ADSR, maybe a filter if you want, although that's not necessarily in the cards for us today, and then something to attenuate the output. The attenuation is important because our speakers work on a different voltage level. They're on a consumer product voltage level, not on a musician voltage level. My friend once plugged his headphones into that level, that higher voltage level, and the coils in his headphones were actually able to tolerate it. He said the music was very soft, but very accurate. But no, we put it into an attenuator, and that way it doesn't blow up our stuff. Line out is like, I think up to a volt, and it's offset. But anyway, nobody can agree on where middle C falls. Is it at 4 volts, 3 volts, 2 volts, 1 volt, 0 volt? It depends on what era you're going for. Mutable Instruments uses 2 volts to be C4. Which one is this for? MIDI note 60, which is C4, although it's debatable. Some people say C3 is MIDI. But the frequencies, of course, of all the Cs are known and in lists. I decided to actually go with the last one here with the MIDI output. I decided to go with the last one because C4 is equal to 4 volts, C3 is equal to 3 volts, C2 is equal to 2 volts, right? And I can detune that if I feel like on the front panel of the device. Getting into grains and how you can change pitch without changing the length of a sample is fucking nuts. Yeah, there's some hardcore math that goes into audio stuff. Best analogy I've heard is that grains work like video works and FPS, so you're interpolating. Yeah, well, anyway, so with us, it was beats, measuring beats. If you're hearing beats of your two tones together, and the way I did that was not actually by measuring beats or outputting any sound. I did it on the oscilloscope, and I was just literally just looking at the waves and seeing whether or not the wave was moving in either direction. Because if it's moving in either direction in comparison to the tone that you're tuning to, then it's off. And if it stops moving, then you're in tune. And so I had to do that, going back and forth between the adjustments, the slope and the offset adjustment, in order to get low C to agree with high C. And I think I did it. I think I did it on the VCO. I think we actually have that done. The ADSR. What I did with the ADSR is I originally built this with transistors that were not through-hole. They were surface mount transistors. There's a beautifully made table on MIDI hertz here. Let's take a look. I may have already had this open and might have closed it. But voltage range depends on the circuit components. You can have 5-volt logic or 3-volt logic, but you have to do the range management to adhere to the specs. With the modular synthesizer, internally, your module might be using 3 volts or 5 volt spec. Generally, if you're I mean, if you're doing analog, it's 12 volts, but if you're doing something digital, it'll be 3 or 5 volt tolerant. But then when you output it, you put it through an op amp and bring it up to the 5 to 10 volt standard. So I decided to do 1 volt per octave, as C note of N is equal to N volts. So C4 is at 4 volts, C3 is at 3, C2 is at 2, C1 is at 1. C0 is at 0 volts. Now that means that I can't go into the negative C's, so if I try to do like a bass line, or like a real low bass line, that might not line up properly, because this module that I bought, because I decided that I didn't want to monkey around with MIDI output, and so as a result, I don't get the full features that I want, and I get some features that I don't want. My dog is going nuts. Willow! Sorry about yelling. There's somebody walking by outside because it's like an extremely nice day, and so she's going absolutely psycho. You guys probably can't hear on the mic. It's just very distracting for me. My corgi is a very good guard dog, but we didn't ask her to have that job. She took that job on her own. This goes down to 0, but it doesn't go below 0, even though it does have access to negative 12 volts on the header. It does not go below 0, and I really wish it did, because then I could go in the low C's and do bass lines. I'm not a particularly good musician. I'm hoping that magically I'm gonna be like friggin' like the next Toby Fox when I hook all this stuff up together, and I'm gonna be making these haunting and beautiful synth lines. That's not gonna happen. I sang in high school, and I was in the select music group right when my voice was changing, which was really humiliating to get out there and go with some of the notes. I am a baritone, and I somewhat know how to sight read music, and I've forgotten all of that and had to go on a huge review course on how our music work, because I mostly did math in college. I took piano lessons as a kid, but that didn't really translate over into anything functional. I was able to, after the Adam Johnston review of Kimba the Lion, this giant extensive review, it's a really good video, long, great video. I was able to take the song from Kimba the White Lion, wah, 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 and I figured out how to play that on an automaton. That's something musical that I did recently. I forget how. I was gonna say about unibipolar, but there's a nice thought on the 1-to-1 ratio. No need to do weird stuff. Yeah, there's no N-2 going on, right? But I might not be able to get to those nice low tones. But I will if I detune the thing. If I decide that middle C should be like a couple volts up from where it is, I've got to find a coarse tuning knob that I could use. Good post the other day on Reddit. Somebody had a LoRa radio, and a poster asked what it was, and half the comments were bomb. I think I saw that post. Yeah, somebody had a LoRa radio that was hooked up to their cell phone. And if you go to my Discord, Madam U, there are more than a couple of LoRa heads there. They're very excited about that. I have one of the modems, or the ICs, they're the developer things that they use. I haven't gotten anywhere with it. I do want to eventually set it up, but it sounds really cool. It's just like, hey, let's make a new thing that's not the internet, and it's not IRC, and it's not, it's peer-to-peer and all that stuff. I'm in an area where I don't think I'll be able to actually do anything without sending up a balloon. And I'm not about to send up a balloon, because then the HOA will launch mortars at my house and blow it up. I didn't really choose to live here. Anyway. The Millennium Paradox, the Millennial Paradox. I didn't choose where to live. Anyway, so 4 volts. I'm just doing C4 is equal to 4 volts, right? Nobody can really agree on it, so I'm right and everybody else is wrong. We need to test to see whether or not the ADSR works, because that's a crucial component in the synthesizer. This is a surface mount transistor. This is not. I took all the surface mount transistors because you can see here, I'm sort of wedging my own technology into this and deciding to use surface mount transistors. This is mostly an analog ADSR. It comes from a place called Nonlinear Circuits. I like their stuff a lot, mainly because they're super duper loosey-goosey about all the rules of putting together a PCB. This is heinous, and I love it. It's like nails on a chalkboard to somebody like me who has professionally designed PCBs in the past. Oh my God. But it gets the job done. It's sort of a point-to-point wiring that just gets it done. It just does what it needs to do. So I put together all of the electronics and I tried to surface mount everything, including the transistors, but the output from this little guy right here is not all that compatible with these guys. I wish it was, but it's not. It's sort of a weird design. It makes putting the resistors on like a typical transistor switch circuit easy. It makes it so that two of the things you typically put a resistor across of are right next to each other, which makes for a kind of confusing output. I could go into details about that, but I won't. So I have the right diodes. I now have the correct transistors because I substituted a jelly bean part, which is typically okay to do if whoever designed it is using jelly bean parts. But when you're using transistors the way they are in the circuit, an ADSR is going to be using transistors not just as switches. It's going to be using them as amplifiers and stuff. Then you get into the territory of the difference between transistors making a big impact on the function of the circuit. So I plugged this thing into power and nothing happened. We have to do a comprehensive sort of fix-up on this thing. Then we'll get out the big frame, the big rack frame, and I'll start putting boards into the rack, and we'll see if we can actually make something that makes sound. It'll be over these speakers. I don't know if I want to go through all of the trouble of trying to plug it into the mixer or the Focusrite 2i2. We maybe could do that, but let's start small. So I put in the BC547 and the BC557. That's exactly what was called for by whoever designed this. Nonlinear Circuits is sort of known for every month coming up with a new board. And they put all kinds of little like silly memes about inserting circuit boards into your butt and stuff like that on here. This one has a shout out to Randy and Bill, or shout out from Randy and Bill that was obliterated by a screw. Randy and Bill send their screw. Randy and Bill send their pan-headed laptop screw. Well, that's nice of them because I like those screws. All right, so we've got all the right transistors. They're all in the right direction, theoretically. All of my solder joints are completely immaculate and none of them can be criticized in any way whatsoever. I guess we'll find out as we go. With these modules that I've put together myself, it kind of stands to reason every now and then that sometimes the stuff doesn't exactly connect properly due to the solder joints, and sometimes it's because they're surface mount parts. Sometimes it's just needs just a little bit more heat to encourage it to work properly. Let's see if we can actually get this thing to do anything. And the ADSR is fairly far back on the totem pole of things in a synthesizer. I think we're going to have a couple floating pieces around here, but I mean, we can observe the output of the ADSR on the 10-volt spectrum with the oscilloscope, which means that we won't be listening to it. We'll just look at it and be able to ascertain whether or not it is working on an engineering basis. And then when we put stuff into the synthesizer, we can then attenuate it and put it to the speakers. I'll not worry about attenuation right now because we've got the scope hookups. These are BNC to 1/4 inch mono or 1/8 of an inch mono, 3.5 millimeter mono. These things are awesome if you've got a good scope and you're doing stuff with synths. You can go right into the scope from this stuff. It's cool stuff. Let's turn on channel 2 and turn that up to the right voltage. Hold on. 3.6 and give us a little bit more time. And then let's pull the scope up. Pull the scope up. Scope. That's where it should go. Frameless scope. There it is. Oh, it's a little small. Let's put them down in a corner. The window for the scope is blown up out of control because of the little shadow generation thing that I've got. This has like an offset to it that's huge. Like the window goes all the way out to here. That's just OBS stuff. It's just the bounding box of that thing is huge. Okay, so yeah, there's our scope. I've got it set to 6 volts. We can take a look at an output here so I can show you guys, at least on this thing, without the MIDI thing controlling it at the moment. I can take the sine wave, which is, well, we can just see a sine wave of C6. That's that. Sine wave of C2. Let's tune that in because that's the low one. Move the trigger up so that it's just locked in on a different part of the waveform. It kind of stabilizes things a little bit. So now we've got our test set up, and if I were tuning this VCO, which is plugged into power currently, so that's actually on, I would send the note per volt signal into one of the CV inputs because they're connected all the same to each other, and then look at a sine wave down here. And you can see C2, and again, this thing has been powered on for a little while. Some of these VCOs and some of the VCOs that I have, the alternative ones, one of them has a cool filter on it, and I wish I could get that one to work. Anyway, some of these VCOs, I got the Oscopy. Yeah, we're getting scopy with it. We're getting hyphy. Yeah, you can see even just touching the metal of these inputs, it'll detune it a little bit because it's adding sort of a chaos voltage to everything, a 60 hertz volt weirdness that's not getting filtered out properly. So that's the level of technology that we're dealing with. I would have it no other way. I want all the weird proclivities that come with this thing. I want it to be really, really weird and moody. But anyway, so C2, the voltage level of 2 volts is being put into this thing, and it's being interpreted into a sine wave that is, what was that again? 65.4 hertz. That 65.4 hertz is as accurate as this scope is willing to get. It jumps around a little bit, but I put in tuning parameters into the programming for this microcontroller so that these I2S outputs will output a certain waveform, and I tweaked it just to be just right? So that it definitely puts out the right frequency. Now that's very involved. I probably should just get a tuner and make sure that the tuner says that everything is okay. But I took a more engineering standpoint to the whole thing. So anyway, that waveform is being outputted as accurate. What if I jump to a different waveform? And I programmed all this into the Arduino. This is the middle C. This is C4. I did not tune it to accurately hit C4. So if you were listening to this, there would be a lot of beats going on right now. It would be, you'd be hearing a lot of beats. I did it the oh bother way. That's a good way to say it, yeah. The most convoluted but most accurate way. So if I go to the high C, yar har fiddle-dee-dee, oh, it's still not tuned at all. Okay, cool. Just tweaking the fine adjust a tiny, tiny bit until that waveform stops moving. And it's important to see that there's the same amount of waves on the screen. That's kind of hard for you guys to see, isn't it? I should make that a little larger. Still hard to see. That may be just the speed that it's moving versus it populating it on the intranet. So yeah, I can fine tune this and get the waveforms to kind of match up. You can see it goes one way if I go too far in one direction, the other if I go the other. My problem is that when I hit that middle note, oh, see, now this is off. So this is a different tuning thing. This is a screwdriver goes into the whole thing. Whoa, too far. And I don't know which one I'm adjusting. I don't know if this is the rise or the run. C4 is still off. C6 is way off. Let's go over here and adjust this one. I need to, there it is. And this could be just because the shop is a little hotter than it was yesterday. And that's sort of how you do it. You go between these two adjustments and you try to get these correct. Now, there is a margin of error for this stuff that we're probably within. Ah, balls. It's like barely any movement because this is one of these one turn or like not even a full turn pots. So every adjustment that I do on this thing is like microscopic. It would behoove me to replace the potentiometer with a 25 turn one because those hold their adjustment much better. Nice. So then we jump to C4. C4 is always going to be off. C6 is still off. I could be detuning this thing right now. If you lived here, you would be detuned already. Come on, buddy. I have the knobs locked in sort of a central position. That's close. This one's barely going to need, like if I just poke it with a screwdriver, it locks it in. Yeesh. That's getting closer. This one's getting closer. You can do this until you are certifiable. Does that look right? That looks right. You can see it's wandering through the tuning too. Weird stuff's going on. I'm going to call that, I'm just going to call that's tuned. I'm just going to call that tuned because there's not really much I can do about it. That one's moving this way. This one's moving this way. This one's moving this way. And I can sit here, and I have, sit here all day and tune it. No, I don't want to do that. So there's other controls on this thing. There's other features of the synthesis of this VCO. There's like PWMs and stuff like that that can be controlled. And it actually is a little bit weird because when you start messing with these, it can actually change the frequency of the output. So I think I'm being a little bit too crazy when I'm going through all of this with such precision. So anyway, that's the VCO. We have the VCO working. We need to see if the ADSR does anything. And so I need to plug this thing into power, and it needs to be metered power so that we know if we're doing an overdraw on the current. So I think these are that. What's that one doing? It's going all the way up to this tester. So I think I have 2 metered supplies, and that's these 2. Unless I plug this thing in wrong. Oh, whoops, that's on. I want this on unmetered. The VCO does not need to be current measured because we know it works. The ADSR, we do not know if it works. So I'm feeding the power cable out, and we're going to see if when I plug it in, we get these milliamp meters down here to jump up crazy like. So unplug you. And so taking that over here. Yeah, so this is the linear circuits ADSR. Plug it in like this. Nothing happens. Not even warmth on the board. It's cute. I don't know if it wants to be called cute. So I feel like something early on is kind of not functioning on this thing. Because like nobody's heating up, which is good, but it's also kind of scary. So the ADSR, what's the IO of this thing? I don't think we need the build platform. No, there's the circuit. That tells us a little bit about what's going on. ADSR 312 front panel, gate, trigger, and then 2 outs. Sorry, I'm such a girly. That's okay. I love cute things and it's fun. But I also just act up the part, so I gotta act manly. Otherwise I'll have to trade in my flannel. Wait a minute. It's gate and trigger. But I thought it was gating and triggering a waveform. I thought you would take the waveform into the ADSR. Oh, unless this is designed to take a gate and a trigger, and then it outputs a voltage level to a voltage controlled amplifier, which I have. I have one. That's what we're supposed to do. I forgot. So I need more stuff. I need more stuff. We can feed a gate and a trigger into this thing. So if I feed a high-low signal as my gate, and there you see the voltage level did a thing. It's doing a thing because it's got a high-low signal going into it. And I take the trigger output of this thing. Let's see. Trigger output, which is this channel. I've got a pulse and a triangle wave. So the pulse I put into the gate. Technically, we should be doing ADSR stuff. And I'm actually excited that we're getting a signal out, and I see my LED is doing some stuff here. This is a very loose plug. Oh, I didn't plug it in all the way. That's why. So nothing's going on with the high-low right now, right? I've got everybody turned all the way down to the left. And so attack and decay. Decay's all the way down at the bottom. Let's turn up attack. Nothing. Okay, I'll turn attack to a middle. Sustain. We'll give it a little bit of sustain. And then, yeah, okay, so nothing's working. Situation normal. Everything's broken. When I sing... Which one is, wait, which one is Michael McDowell? Yeah, like when I sing, I'm super manly, like when I sing Kiss from a Rose by Seal. Okay. Can we do a different mode on this one? Pulse at 0.2. Okay, so that's 0.2 hertz pulse. Let's take a look at what that looks like. Cool, cool, okay. Definitely a pulse coming out of that. Where's my pulse? What about you? Oh, it's very quick. Okay, so it's a very quick pulse for the trigger. Oh no, never mind. We just can't. It's hard to see. I'll move this one, or I'll move channel 1 down. So that'll come in and go bop. There it is. See, it's a very, very occasional pulse. Oh, we don't want 26 volts on this. There we go. Bop. So that's the pulse. It's a very slow heart rate indeed. So if I look at the pulse over here, look at all the noise that introduces. Jeez, it's a lot of noise. How do I make that less noisy? Jeez, good Lord. Oh, we're not introducing the pulse yet. I need to get another wire. Hold on, let me go get some wires. I gotta go grab some wires over here. I am sweating today. It's hot down here. I guess I could open the window a little more. Couple wires. Where did my wires go? Julian must have stolen them. Julian stole my wires. Where are my wires? We're trying to see if this ADSR works because I did a bunch of editing to the electronics on it. Let me, I'm gonna open the window a little bit more. Let's look at my face. Let's look at the face cam so you can at least see me rolling around the shop trying to mess with stuff. Open this up. Oh, my little kickstand is fallen. I have to get that later. Okay, so yeah, back to this. See what we can figure out. I'm hoping this ADSR works because we really kind of need one. But I didn't know that it would just be, I thought we'd put audio into it and then it would act as the VCA. It doesn't, and I was, in that moment, I was reminded of the existence of a voltage controlled amplifier. I have one that works though. So we need a voltage controlled amplifier so that the ADSR, when it gets that trigger, it will hold a voltage level that represents the amount of audio that we're going to allow through, basically that we're going to, like what audio level we're going to allow through. So if I take a look at the pulse that I'm generating with my tester, and that's over here. So now we've got that pulse rolling through and we can observe that, but it's also going down to this guy. And as well as that pulse, we have these are just little patch bays that I made. We have a high-low signal. So we get a pulse and a high, but nothing is coming out of the other end. And that should, in terms of gating, that should just turn it on, right? That's my understanding of how the ADSR is supposed to function. Let's just look at the Aries 312 envelope generator and how that works, because that's what it says it's based on. And just see if we can get like a bit more of an idea of the theory of operation behind this thing. The Aries AR312 module is a standard Aries music envelope generator. It's engineered to provide maximum control capabilities at minimum cost. Included with the module is a 4-jack patch multiple, allowing a single output to be split and routed to 3 different inputs. The module has 4 outputs, allowing this module to simultaneously and conveniently control 4 different modules. ADSR allows for perfect control of dynamics for your notes. Exact control over the rise and decay can be attained to achieve the precise sounds you're looking for. These are all just marketing words. The envelope generator provides a control signal, which is usually used to turn on the voltage controlled amplifier. Yeah, okay, I figured that out on my own. I didn't need your help. I know, I'm a cool guy. Or a voltage controlled filter, when connected to the keyboard, gate, and trigger, it provides an output whenever a key is depressed. I'm sad that they're sad. The 4 controls of the envelope generator, attack, decay, sustain, release, allow for changing the dynamics of the note. For example, the ADSR output is connected to a VCA output with some signal at the VCA signal input. Then the output will rise from 0 when a key or the ADSR manual trigger is depressed. The rate of rise set by the attack control, it will then decay, set by the decay control, until it reaches a level set by the sustain. When the key is released, the signal will decay to 0 at a rate determined by the release control. So, in the business of the signal being high, yeah, okay. Look at that. That's awesome. Look at all that electronic. And then this is the circuit that Nonlinear Circuits decided to copy and make slightly more modern, although I really wish Nonlinear would let the church of the surface mount device into his life, into their life. 4 milliamp and 2 milliamp. I think our current consumption is okay. We saw some operation of the device, but I didn't see any. What the hell is it doing right now? What is that? Why is that weird and broken? Yeah, see, that's what it should look like when I touch this thing. It writes itself. I don't know why it does that. There's something weird about the module tester that I built where like 2 of these channels don't quite do what they should. But regardless, we got this thing partially working for a moment, so I don't understand exactly what's going on here. So maybe high-low is not what I need. If I just give it a DC gate voltage and a trigger, what can the output then look like? Let's get let's get this channel to be our output. So we're sustained, I guess. And every time a pulse rolls in, it gets a little higher up. Maybe I do need to hook it up to the MIDI thing. Maybe the MIDI thing will give us the right. Where are my headphones? No. We're not making anything musical at the moment. Yeah, let me plug it into the MIDI thing. So let's turn this all off. So apparently using just the MIDI controls, I can create some type of envelope generator that can go into an amplifier. So let's put that to the test. That's what we're testing now. We're going through each of these piece by piece. We know that we can create the note. Now we need to shape the note. This thing also has some alternative controls as well, but we'll leave those for another day. So we need to go back into MIDI mode for this. MIDI mode. But we know that the MIDI thing is tuned and it works, so we simply need to observe where it tells you where the stripe is. It says red stripe on the bottom. Really make sure that we're not plugging that thing in wrong, because 9 out of 10 of the synthesizers that I ever see here are broken in that manner. And we'll attach that to our test rig. I do have MIDI input to the test rig, I just don't have any circuitry behind it. There's a MIDI plug on the side of this thing. And it would be good if I could build one of these things into this, which I totally can, but it's a lot of work. What? What about me? What? What's unbother? This is so funky, I love it. We're having fun, I hope. I just get unbother and then no follow-up? What'd I do? I don't know. What? Can a Bluetooth dongle get hot enough to bend? No, that sounds super turbo bad. That's come because, you know, stuff like that, if it bends, it's not good. Let's put the front panel back on this. By the way, here's something about modular synthesizers. If you're going to build a bunch of the kits like I am, maybe you'll learn this on your own, but do you guys see the problem here? I give this rant every time we work on modular synthesizers. Do you see what the problem here is? You might not. This is the cheap connector for the 1/4 inch, 1/8 of an inch mono jacks. This is what's called, they call this the Thonky Kong. But this is not this is a 3.5 millimeter or a 3 millimeter LED. The old school one is a 5 millimeter one, but the 3 one's okay. This is a bi-directional one too. Anyway, this connector is a different style of Thonky Kong, and it is the one that will break your synthesizer more often than not. It has these wire lugs, first of all, which is not what the regular Thonky Kong has. The regular Thonky Kong has a through-hole pin coming out of it, and you can see very specifically there is a little shoulder in the metal. There is no shoulder in this metal, and so when you tighten a bolt down on this, if you do, assume a uniform density Thonky Kong connector. If you do the physics thing on it, you have the little dot, and you have an arrow pointing in one direction, an arrow pointing in the other. When you tighten this down, it will put pressure on the plastic, which will then try to extrude that rivet. This collar is only held on by a little rivet at the end to a metal plate with a hole in it, right? It's only this little bend of metal right here that fights against the screw that goes in and holds this thing in place. So if you over tighten this Thonky Kong, what's the the DK Thonky Kong? Anyway, you tighten that thing down, and that will extrude the threaded barrel part through this piece of metal very easily. I hate these connectors. They're very bad compared to the other ones. The other ones put all the pressure on the metal, and so you can actually tighten them down without ruining your whole device. So it's worth noting, be careful when you have to use these. I have to use these because the through hole is so big that I could only use these things. If I break one of these, I'll probably desolder a lot of them and replace them with proper Thonky Kongs. Now I'm putting this thing back together because I want to put it on the front panel. I want to actually hook it up to this panel because supposedly with the keyboard input, we can control this thing. I have no reason to believe that this thing is not a functional piece of equipment. All of the soldering on it is immaculate. Not really, but I mean, you know, whatever. Now, keep in mind, chatters who may feel self-conscious, I do not mind if a singular person fills up the whole chat with messages. That's okay in this stream because things get quiet. Things get quiet with lower numbers in streaming, and it's totally acceptable that, you know, Weaselbox is leaving a bunch of messages, and it's great because I need that little bit of interaction. It keeps me going. Now, there's no obligation. There's no obligation to chat. I'm just saying, if anybody sees it and is like, oh boy, it's totally fine. Encouraged even. See, I have to hand tighten these. I can't use a tool on them. Although they do sell a tool to tighten these. You should not buy that tool because if you're using these little collar guys, the little rounded ones, then if you go beyond hand tight, you can break your device. Why do the guys always be quiet when I'm around? That's my stream. That's not you. What's up, Swizzler Circuits? Annoying, I'm sorry. No, I'm literally just saying right now that you are not. That is the opposite of exactly what I was saying. How about this interaction, farts? You know, better than nothing, I guess. All right, ADSR 312, we are putting you on the rack even though you're not ready yet. And I'm going to put 2 bolts in there so that I can just willy-nilly plug into everything, although Willie Nelson has nothing to do with it. I need 2 more of the nuts. So let's get 2 of them from the stuff below me. This is where all these are stored. I'm relying off CC. I don't know what that is. Trying to think if I have another dongle in my headphones. Oh, for the Bluetooth. Yeah, I don't know what the hell happened to yours that had it drag like that. Those dongles are supposed to be really small and tight to the computer so you can't knock them and bend them. Oh, closed captions, I see. How accurate are those? I don't know. Wait, these aren't the right things. These are standoffs. Wrong bin, wrong bin, wrong bin, going back down. I'm going back down under the desk. Which one of y'all? There it is. Maker Beam is really convenient for modular synthesizers because you can make stuff like this little rack holder. Yeah, how are those live closed captions? I know Twitch does it, and I think YouTube does it too. I guess it's got to be relatively good. It's just when I do funky voices, I'll bet it messes up quite a bit. Gives you the wrong impression of what I'm saying. Father, I can't believe you would say something like that. It's like, wait, I didn't. I didn't. This stupid closed caption AI. It's hallucinating. So I can keep up with what you're saying. Yeah, people who don't have English as a first language may have trouble. I talk very quickly. I babble. All right, there's two more. I'm just going to put two in. I should hold it. Oh, you're actually running an extension to do that. Interesting. Yeah, I know there's like closed captioning that Twitch can do, or, you know, I can run an extension for it, but I haven't bothered to test any of that stuff out. See what it's like. For some reason, I can keep up on good days. I see. All right, so ADSR, we'll add that into the rest of the things so I don't have it hanging in the breeze, and then we will add MIDI to the equation. So there just happens to be this MIDI plug sitting here. MIDI was invented in the Stone Age in order to make Kraftwerk able to operate remote instruments. It is an old protocol. It's from the 80s. It's very rudimentary. It basically gives you a message with like an attack or a velocity and a note number, and different notes are assigned to different things. You can learn it in a day. You can look it up online. You can find a web page from 1996 that has all of the specifications for MIDI and how to program the signals and get them working and stuff. And then you can jump onto an Arduino, and with just an opto isolator and some love, you can then send MIDI protocol messaging around. There's a lot of different stuff you can do with the Arduino and MIDI. It's very, very cool and versatile. Incidentally, this MIDI to CV converter has an Atmega 326P operating it. This thing is obsolete, so Erica Synths puts out kits of their stuff that's obsolete. If they're not selling it anymore, they let you build them, which is kind of neat. I like Erica Synths. We've done a lot of reverse engineering on their stuff before. We had Julian had a reverb from Erica Synths that was nice and thin, and it uses a chip that is just an ASIC that does reverb. And in order to get that running, they had to send it a clock signal, and so they have this AT-Tiny 13, I think it was, little AT-Tiny microcontroller in there. I was able to get it programmed with Arduino, make it do all the functions except for that clock output. I almost put that into the thing, and then we discovered that he had a second one, so we pulled the hex file off of it and put it on the first one. So we fixed the old one. Crazy, crazy times. Now, all things considered, I should be able to trigger this thing on the second channel and have an appropriate attack and decay signal coming out of it, which is this whole ADSR envelope. So I should be able to get something that has an attack, a decay, a sustain, and then when I release the note, it releases it at a certain rate. We're going to look for our wonderful little peaky mountain diagram on this thing if I can hook it up properly. And my dog starts barking. Barf. And so I won't use any of the automated tester things. I'll instead use this thing right here, this MIDI generator. So we don't care about the CV gate. We care about the, what is it? Well, no, what other signals do we have coming out of this thing? Okay, so let's take a look at what the MIDI thing is doing. what it do. And let's see, we'll have it on one voice mode, which means gate 1 and gate 2, I think, do separate stuff. Clock out, we don't have anything to do with. Mod, I think is, we may need mod and CD gate going into this thing. And then I think it'll do what we want it to do. Let's see. So power on, keyboard all the way over there. And so if I hit a key, bonk, so that's C4. And that is the gate output. So as long as I'm holding down the button, which you guys can't see, maybe I can get that on camera. Okay, hold on. More setup stuff. I gotta rearrange a little bit more. More rearranging, more stuff on the desk, which is gonna lead to a lab-avalanche, which is when all the stuff in my lab falls down. It's an offshoot of an avalanche, only it's full of stuff that I own. Okay, mic cable's getting in my speaker cable. We don't need speakers yet, so I'm gonna put speakers aside. I'm gonna try to get the keyboard down here so that you guys can see me hitting keys and then stuff happening when I hit keys. It's the magic of music as we get through all of the different functions of a modular synth. Irons off? Yeah, irons off. Earns off. Earn, earned, and earn. Erin, earned, and iron, earn. Earn, earned, and earn. Stuff over here. Okay, almost there. Screwdriver, tweezers, thingy. Listen to the avalanches? Is that that's a thing I don't know. We don't have that kind of thing here. We have a lab-avalanche. Look at all this empty desk space. Tell you, nature abhors a vacuum. I hate that I have this circuit sitting here. This is a lamp. This is a makeup mirror. A touch-activated, dimmable makeup mirror. If you hold your finger down on the thing, it'll dim the LEDs. I didn't explore that when we took it apart, but this is like a perfectly suitable touch-activated lamp. I don't build touch-activated lamps. Every lamp that I build is Tasmotized. It's got a Tasmota controller in it so that I can control it with Node-RED and make it automated in some way, shape, or form. So that is a totally useless circuit to me. I should have like a giveaway. This USB cable is making me annoyed. That all back there, clear off the bench. And then now we have a little, why is there a hammer? That over here. Yeah. A place for everything and everything in its place. Go to your home. I was brainstorming a project and I told a friend of mine about it, a friend that I actually met for lunch yesterday. And it involves one of those little kids' cars, you know, the Peepo Drive car. We have Peepo Drive in the emotes, but the little Peepo Drive car, and he found one the same day. He found one. It was the wrong color scheme. But I really wanted to use a mobile streaming rig with one of those little Peepo Drive things so that you have a view over Peepe's shoulder and he's driving the little Playmobil car and make that into an RC car that's rather slow, take it to a con. And so with the over-the-shoulder view, I could put a cell phone on the A-pillar and that could be chat. And then I could paint on the top like Twitch TV Oh Bother. And I could have the little Peepo driving around and it would be so cute to have that view over his shoulder, because then you can go run into other streamers' ankles. I could blast all of their ankles into space. It would be amazing. So here is sustain, or rather the gate signal that comes out of hitting a note. What is this one? This is the note per volt signal. So this one changes a little tiny bit depending on what key I'm hitting. I found an old dongle. I hope it works. Good luck with your dongle. Sounds like something else. The Aaron Earn and Iron Earn video. Yeah, I love it. I live near Baltimore. Not totally close to it, but you know, I've driven through a couple times. Earned, and earn. It's just like a good, honest, like, holy shit, wait a minute, we can't say that. We don't know. our accent does not allow that. That's so weird. And then they, of course, try to say that Aaron earned an iron urn. That's so awesome. Love that video. Mod, I believe, is our attack. Yeah, see that? Hit it softly, hit it hard. Soft, hard. Okay, cool. Maybe I shouldn't call that soft and hard. That's a little loaded. Yeah, we really sound like this realization. It's kind of amazing. Okay, so how do I put that into an ADSR? An attack, decay, sustain, release. So for release, I need the gate signal, which is going to be this one. I'm using channel 2, although we're in one channel mode. So that is going to be our gate. So that gives us a little bit of something, something there. And then, which one do I want to be? Well, the note per volt, I don't want to be the blah, 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 blah. Idea. What's your idea? Driver unavailable. So we will monitor this mod over here, and then I'll pull that back and put it into the gate of the ADSR. So this is why your modular synthesizer becomes this big mess of wires. We have a couple different signals that are coming out of here, and I showed you them on the oscilloscope. Basically, we have, depending on how hard I hit the key, this voltage level goes up and down. It's not really so much of a trigger signal as this thing is looking for. And then this one down here is a gate. As long as I'm holding down the key, this will go to a different level. This one releases though. So if I hit one of the keys here, there we go. We're getting a sustain, although sustain could be a little lower than that. As an ADS is over here. So yeah, sustain I can set to whatever voltage. And then the decay, if I turn it all the way up, it should hold. Oh no, that's a higher decay. So there it is decaying. Quick decay or slow decay, that is above 10 volts. Geez. So we can turn down attack. And there we get, and if I release, that's this one. So that's a slow release. This is a quick release. Okay, ADSR works. Hey, I didn't expect that. You guys can kind of see me hitting the key over here. There's a lot of stuff on screen, but I hope you guys understand what's going on here. We're using the voltage levels to trigger, and we're getting a unique waveform shape that will allow us to go into an amplifier. And that amplifier will allow the audio waveform to be shaped by the ADSR's voltage level. So as I hit these buttons, I would send one of these signals into a voltage-controlled oscillator. So we know the oscillator works, we know the oscillator's tuned. Where is the... Oh, there it is. We got it right here. Can you make it talk? Let's see what we can make it do. What'd it do? What'd it do with that mouth? Okay, so I need a voltage-controlled amplifier, and I know this one works because I've worked with it before. Where is it? I'm looking for it. It's something that I printed a whole thing out. Oh, and then we need, if we're actually going to output the signal, we're going to need an attenuator. So that's that. That is a single-channel attenuator. It's not my super-duper amazing mixer. Here's a voltage-controlled amplifier. It uses a BCM 15 chip. It was a comprehensive kit. I decided to allow it to be through-hole. I think I adjusted all this stuff so that it's at least in a good place. And I have used it, and I do know it works. It was just kind of a little bit of a complicated build. I measured the circuit board. I took it into hashtag AutoCAD ad. This is not an AutoCAD ad. We're not doing AutoCAD today. But I made these brackets that would hold the whole circuit board at this angle so that I could tighten up all the ins and outs and not make it such a large piece. That's a nice amp. You don't know nothing about it. I don't either. I guess it works. I don't know. Is it a nice one? I don't know. It's analog. So yeah, this is everything we have right here is all of the components that would go into a synthesizer. So let's get it together. I need a larger case. Turn this thing off, and let's get all these out of here, and let's move it all over to the big thing. And then maybe, just maybe, we will be able to make something that sounds like sound. I don't know nothing about it. I just looked it up on like ads, the kits that were available from a website, and I kind of like pieced it together and it seemed to be okay. But what we're doing is we're making the most boring iteration of a synthesizer out of just the basic components that minimalistically get you to something you can call a synth. Since this project has stagnated a little bit and I've needed to kind of get to a conclusion with it, we finally got each individual part working and we know how they work. So I should be able to make something where I hit a button and it makes a noise. And then maybe later down the line, I can find the giant AC power supply for that big keyboard that we have, set that up somewhere. It would have to be to the left here. And then maybe I can mount the two boxes at an angle behind it. That's a whole setup though. That's a whole thing. And then I can be Dracula. I'll have to put on a mask. Am I going to need this? I'm going to take this with me just in case, because we like to see stuff on the oscilloscope. That'd be a sweet setup. It would be really nice. What's up, Gonad? We got the ADSR working, so that means that I have every component that is needed for the most basic of basic synthesizers. And we can put this all together and we can have some fun making some tunes. This is kind of my happy place right now because this stuff is a little bit more circuity and it's more with my hands instead of with my computer. In the future, I'm going to be doing stuff with the Raspberry Pi, trying to get OpenGL working on the Raspberry Pi, and then with OpenGL working on the Raspberry Pi, I can get Project M to do some visualizations on it. And from there, it is trivial at that point to get the Raspberry Pi to output really cool looking visualizations. This is something that I've done before with visualizations where you get a grid of pixels and it's a bunch of RGB LEDs that are separated by a lot. But that creates a sort of a nice complicated visual. If you choose the right plugins, it'll look like you're looking at a complicated visualization thing through a grid. It looks like you're looking through like a grating. Where do I want the big thing versus the keyboard? This is tough. This can go back here. I'll keep the scope on because we'll want to get our scope on, I guess. I got a sweet amp I've been saving to use. Nice. Nice, nice. I'm pro sweet amp. Okay, so synthesizer box is big. It's a big boy. This is Julian's old stuff. His new stuff is much more streamlined and small, but I'm dealing with secondhand stuff here. I'm always the little brother. Always the little brother. And I hopefully can explain this stuff as I go through it. I think we need to actually put this on the stool. Let's move the light back and get the stool over here. I just simply don't have room for it up top. A lot of dust. Ugh. Okay, so your modular synthesizer case is going to have some basic components to it. Typically, you're going to have 15 volts input, and then you'll have a power supply and a distribution board. And hopefully you don't buy the distribution board from where I bought the distribution board, because apparently the person that I bought the distribution board for snapped and went completely sort of neo-Nazi on everybody. And it was sort of a whole thing, and it wasn't very wholesome. So don't support them with money, ever. I didn't know this until Julian came in and he said, don't buy from that place. I was like, oh, okay. Okay, I guess I won't. Yeah, I don't know, whatever. Who the fuck knows? O-scope signals, this is the MIDI cable. Let's get, I don't really know where I want to route all of my wires. And this could technically fit up here, but let's just keep it right here. Because yeah, we could do it. I really would like something that can hold that like this. That would be very nice and convenient, wouldn't it? What's up, League Gamer? I mean, I could just put it up at a 90-degree angle, but then you can't really see anything. So I guess we're just going to lay it down. Wait, maybe I might have something. Hold on. Might have something I can prop it up on. I mean, there's this piece of 80/20, but it's not tall enough. That'll only give it a slight angle. Well, slight angles, I guess, all we can do right now. In the future, maybe I can get the 80/20 to sit over the keyboard. Make a nice little, like, swing rack for the whole thing. Cool to see you back at Synths. Never left it, but I have been working in the background, and now I'm working in the foreground. Do this before I freeze out the cameras. Move the keyboard over here too. It'll free up my mouse area. There we go. ID light right there. Okay, that's pretty good. All right, so where do we start? Power. The power supply for this thing is over the other part of the shop. Hold on, let me go get it. Start with power. I've got this brick that does 15 volts at a certain number of amps. I also need power cables, so I'm just going to grab everything that I've got sitting over here. These are all of the power cables. I actually bought 2 different sets of cables and adapted one to the other. M-Audio Oxygen B brings back memories. Yeah, we had one of these was on a table at the festival, and when you'd hit the buttons on it, it would set off different samples that were all synced up to each other. It was basically Ableton, it was like Ableton where you could never fail, right? You could press any of the buttons and they would make music, supposedly. A lot of people thought they were making music, but they weren't. This is not the right adapter. 15 volts, 4 amps, 60 watts. I think Julian took my adapter from the end. That may be what happened. Hold on, let me find the adapter. I didn't make a USB-C input for this one. I probably should now that I have the circuit boards, but I don't know where they'd go. What are you? 15 volts, 3 amps. Okay. That one has a big 3-pin connector, and it has a slightly different barrel on the end that I don't think will fit either. So, what happened to my power? This is annoying. Over the months, Julian... Ah, there it is. So there's the barrel plug adapter. I don't like this because it sticks way far out. This is like an accident waiting to happen. I would rather do the USB-C thing. There we go. That fits in. It gives me this nice big moment arm that can be knocked into and blow up all of my audio equipment. Yeah, so power supply is one consideration. You need 15 volts, not a ton of amps. You don't need a ton of amps. And then you need to convert that to plus and minus 12 volts and maybe 5 volts if you're feeling frisky. All right, that power's on. We're going to turn it off. So, where do we start with a synthesizer? Well, I've got a keyboard sitting here, so I kind of want to be able to have it playable like it is a keyboard. So we start with a MIDI converter, and this will convert MIDI into the stuff that we need it to be in order to trigger the subsequent modules. So I need the bolts that I'm going to be putting into this thing as well. Let me find that now. I just sort around for that thing. I'm no expert here, by the way. You guys have suggestions? I would love to hear them. Oh, here are the power cables. Wait a sec. These are the ones I need, not the ones that I have over there. I got this big bin full of modules that I've bought and put together. Some of them are functional, some of them are not. Some of them are untuned. Some of them are tuned. Are tuned! Where is the little... I had a little cap that was full of the screws. There it is. Here it is. Keep finding wires, too. Need plenty of those. Okay. Dang, I stink out loud. Today is laundry day. And while the shirt that I'm wearing is clean, the undershirt is not. So I am in dire straits in terms of not being a giant stinky neckbeard working in his little cave doing neckbeard stuff with other neckbeard stuff while neckbeards watch him. That's right, I said it. Okay, wires, wires everywhere, not a drop to drink. MIDI. God damn, that MIDI wire's long. It's cool, we can't smell you. I'm banking on it. That's what I'm banking on right now. Is you guys are unable to smell about it. All right, let's just use this screwdriver kit screwdriver for this. And I need the hex bit. Ooh, how's this set up? Jeez. I do want to get rid of this lower power rail. I'm not dealing with the density of modules enough that I'm going to need every single one of these pin plugs here. I think one of these could feed both racks. Actually, this one could. And then if I get rid of this one, I can put it in the other case that I have that's exactly like this. And then I can set them up on top of that big keyboard. I think that would be really cute. It would make like a traditional looking synthesizer out of the thing. Of course, then when Julian calls up and goes, "Hey, yo, come over with your synthesizer," that would be a little bit harder for me to do if I set it up with a keyboard like that. All right, so let's just get this thing in here. Some of these are way too long. They're just M3s, I think. I don't think they're 2.5. These are just M3s. Oh, power plug first. Hold on a second. You want to make sure that your things have power. And I'm putting the MIDI cable over here because it plugs in from the front, and it's going to be a cable that like hangs down from everything. Technically here might be a better place, but I'm going to put it here just because then it can exit where all the other cables are. A smarter me would put a MIDI plug down here and have like a back plug on this thing. So red stripe symbolizes the -12. It's kind of weird the way that they standardize this. It's one of those things where they have a lot of extra pins because they thought expansion or something like that. You have a 10-pin connector, 2 rows of 5. The top ones with the stripe, that's pin 1 with the arrow on the plastic, is -12. So the top 2 pins here are -12. The next 6 pins, in both rows are all grounds. That is an excessive overkill amount of ground, but they did it that way. They decided that. And then the bottom 2 pins, at least on the 10-pin version, are +12. If you've got any further pins, those are going to be 5 volts and then a CV and a gate signal on the 2 pins. I guess the reason they do the 2 pins like that is because you can daisy chain stuff, I guess. I don't know. It's weird the way they do it, but that's how they decided it. The ancient ones in their council decided upon those voltage levels. We're only going to use the bottom row of plugs just to prove out my theory that I don't need both of these distributors. So bottom row plugs, put the thing down, and then we screw it into the rack. Does this no longer fit now that I've put the power plug in there? That would be deliciously ironic. Oh no, it fits. Don't you think? None of it's ironic, and I really do think I should go to English class and learn about what I sing. All right, and I'm just using hex bolts. Some people get real fancy with the stuff that they use on these modular synths because musicians are stylish people and they like to do weird stuff. Let's bring you guys in a little bit. Bring you guys in a little bit so you can see what I'm doing. Oh, see, that's sticking up. Eesh. I'll loosen that one. It's interesting how much these rely on the front panel for structure. And I guess that's just the way things are in a rack. Yeah, it's like, it just kind of doesn't fit. I gotta like force it down a little bit to fit in there. That's really annoying. My, the panels that I made myself have a slightly different fit than this. But anyway, that kit came with the front panel. I'm just gonna use it. So there's MIDI. Now we have MIDI input. From MIDI, the next thing that I wanna go to is the ADSR, and I wanna go to the VCO. So these two. So what order do I want to do that in? Let's do the VCO. Well, actually, no, 2 connections to one connection to the other. I could split VCO to be down here and then ADSR up here. A bunch of wires going over here, one going down here. This one goes to whatever's next. And then I have the, well, let's just do it in one line. We'll do it in one line because it's a little cleaner. I guess it's not really cleaner. It's just, exactly. What's up, Short Lurker? We're actually putting this thing together into a synthesizer. And I told chat, I'm not streaming tomorrow because I'm going to be working on my car. I promised Short Lurker that I would work on my car tomorrow, and I am. God damn it. I gotta get a bunch of stuff working on my car that doesn't work. Not limited to the windshield wiper. Notice how I didn't say plural. I said windshield wiper because my car has the driver's side one working, which means that I can deal with it for an entire year before thinking that I should probably assess that. And potentially I could take the throttle body off and adjust that because my throttle cable fell out. I don't know what it is with the design of these cars, but boy, am I glad they went to drive-by-wire. And I never thought I'd be saying that because people hated drive-by-wire. Drive-by-wire is when you don't have any physical connection between your foot, the foot on the pedal, the gas pedal, the accelerator, and the motor. There's no physical connection between those two. There's an electrical connection. And so you have this expensive servo that opens and closes the throttle body. That makes it very easy for the engine to determine how much acceleration it wants to give depending on where your foot is positioned. You get to have all kinds of electronic, what most would say interference in between your foot and the motor. I like that. And I don't understand why BMW designed their drive-by-wire the way they did, or not drive-by-wire, their throttle cable the way they did. The last iteration of their throttle cable is a wire, let's say it this way, a wire with a ball on the end. And there's part of plastic of the throttle body that has to turn. And so to turn the linear motion of a ball coming backwards into a turning motion, you just have a moment arm. And the moment arm has a guide on it. So you got a guide that goes down, and it literally just surrounds that ball so that the ball can fit in and then tug this thing in a circle. But they didn't lock the ball down in any way, shape, or form, right? Like the ball just fits into this little ball thing, and it's supposed to pull the throttle body. So when I blip my foot on the throttle and it suddenly goes this way, the spring for the throttle can't capture it in time, and it just falls out. What? That apparently is the best design they could come up with. Duct tape. Actually was fixed that way by one forum member who wrapped it in tape and put it back in the ball hole, and it supposedly fit in the ball hole a little better. I would at least think it should snap into that hole, but it doesn't. It just sits in it with the two springs fighting each other. I don't know what the trick is. I guess I gotta call a friend of mine and see if he's ever dealt with it before. But apparently you're just supposed to tension the throttle cable to the point where it doesn't fall out. And it's supposed to be something like 85% of throttle is left when you have it adjusted properly. So I've got to get the computer all the way out to the car, hook up all of the German software that yells at you in German if you fuck up. You hit a wrong menu and it's like, I just find you not, and you're like, Jesus, I'm sorry, Klaus, calm down. So yeah, it'll yell at you in German, which is, that's fine. That's very German car ownership. What I don't like is happening here is when I tighten these down a little too far, it'll bow the panel outward because I guess the way it interacts with the lip over here. I don't like that. I'm getting real sweaty. Hold on, I gotta move some stuff here. I gotta move the fan so that I'm basically sitting on top of it. It's very warm down here today. Very warm in the shop down here in the basement with all the bugs and the snakes and the gross stuff down here in the creepy basement. Okay, now we're practically sitting on the fan. Okay, the origin of our signal, the playing of the note on the piano, ADSR in order to sustain a voltage level, VCO to create the note. Honestly, staggering these on the two rows would probably be a better idea, but I'm just doing it this way. And then voltage controlled amplifier to shape the waveform as per the ADSR. This is also a mixer. Shape of the waveform. I must shape the waveform. These are fiddly. And there aren't many ways that I can hook this up alternatively because so far we're making an analog synthesizer. No digital electronics are involved in any of this yet. Come on. What the? Where aren't you? Hello? Find your home. Go to your home. There we go. Okay. Amplifier. And then from there, we attenuate it to go out to speakers. Technically, this should be all the way over here, but we're going to put it close by. And then just in case I need to, I have a distribution panel to go in there. And that's a super basic synthesizer. And we'll get that working in super duper basic mode. The most basic. Now, the thing is, like, Julian's tried to describe to me how a synthesizer functions, and it hasn't really clicked with me at all until I did this, building all the modules, getting them tuned up, putting them all together, and figuring out what is supposed to go where. We now have the most basic form of a synthesizer. What you would do from here is add things like filters, utility modules, things like that. We don't know what we need yet, and I didn't hook anyone up to power. This one, I believe, has a shroud around the thing, so it's a little less ambiguous how I should hook it up. Yeah, that one's nice and easy. Didn't hook them up to power. You want to have a little bit of extra room on your power cables so that if you pull out a module, it's not going to... Well, so that the module can be pulled out. Have a strong pull-out game with modular synthesizers. So that we can plug in over here, and you can see I'm already at a point where I can skip a couple of the power plugs and just go to this mid plug, and I could have a couple more modules down here. So I think with only one distribution panel, I should be able to get away with filling this rack up with analog stuff. The digital one I might struggle with, but I think I can get by. I keep having sound bugs where it repeats one of your sentences forever. I've had that happen on Twitch before as well. I don't think it's me. I think that is a Twitch thing, and it probably has a little bit to do with it trying to catch up to live. I mean, we don't have a ton of viewers in here, so it's usually on my end that it does that. Although, to be fair, the times that it's been happening lately, that's been the fault of my own bandwidth. Or no, that's been the fault of the streamer cutting off. I don't know. All the packet nonsense that goes on with live broadcast audio. Oh no, don't understood what I'm saying. What I'm saying makes no sense. They're barely sentences. Oh, I just powered it on. Whoops. Power off, power off, power off. This doesn't need power. This is literally just attenuating a big signal into a small signal. And then we have our outputs. So let's look at this on the scope, because I've been talking about this in relation to voltage levels. So I want to keep this in relation to voltage levels and see what our final output audio looks like as per voltage levels. And then we'll plug in the speakers and we'll see what it sounds like. So this is a synthesizer. You repeat them a lot, so I understand. I do repeat myself a lot, and that's just the way I kind of do streaming. I could use a much smaller rack with a little distributor in it. That would be kind of fun. Although when we start putting in filters and utility modules, this will start filling in. Okay, so MIDI output from the keyboard. Not necessary with a modular synthesizer, but it is nice for me to learn how all this stuff interacts with itself in order to create sound. From there, I have velocity and note and a gate. Velocity and gate can go into the ADSR in order to produce a more complicated gateway signal. Gate is just on off, right? Unless you have a more complicated control voltage, and then it's like I'm flipping the volume knob around. And so that more complicated gate signal can go into a voltage controlled amplifier control input. The note per volt coming out of this can go into a voltage controlled oscillator that will take that note in and create a bunch of different output waveforms. Now, technically, this could be two knobs, a control voltage in, and a sine, square, etc. output. That could be a thin little sliver on this thing and still be an analog device, which is maybe something I want to think about doing if I ever want to have something that can handle all of the piano notes at once. This thing handles one note at a time right now. That signal is completely unregulated, so it's just at full volume, right? That goes into the amplifier where it will be a synthesized note, depending on how I hit the piano key. The output from that then needs to actually go into an attenuator before it hits the speakers, because this is going to be something like a plus minus. It's going to be like a 20 volt signal going into a 1 volt speaker. So we attenuate it with this mixer here back down to output audio specs. And that's a synthesizer. See you guys next week. No, all right, let's hook this thing up. Let's actually hook this thing up. Get all these power cables out of the way. I'm sweaty. So we're going to look at this on the oscilloscope first. Oscilloscope first. Where is that? It's right here. Before I output actual audio, I want to make sure that every step of the way is functioning properly, and I guess I probably could do that with the attenuated audio, but it would make a bunch of noise, and I hate these noises that musicians make. They sit there and they go brrr, and they're like brrr, brrr, and then they'll hook something up and burp, 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 burp for 90 minutes until they actually start putting a composition together. Oh, it drives me nuts. Hold on, I gotta fix something. I don't know if they're immune to repetitive stress audio injuries or something, but I am susceptible. Gotta find the right tone for the tune. The other thing that I do want to do is actually get that $30 oscilloscope and hook it up to all this stuff. I've also got another project where I want to make using one of those circular screens, I want to make an oscilloscope that looks like an old school oscope that'll do all the modular synthesizer stuff. But again, I don't have time to do all that stuff. We'll get to it eventually. So those would be cool, and that way I wouldn't need to have this up on screen. It's brain damage at its finest. Yeah, but they are wonderful musicians. They do their stuff well. But man alive, can I not tolerate. So anyway, first connections. Let's get MIDI plugged in. That's not MIDI, that's power. MIDI, 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 MIDI. There is MIDI, yes, very good. MIDI. And now we can see on the oscope, using channel 1, we can see, I guess I can turn power on and just leave it on now. Nothing. Nothing. MIDI's on. MIDI's plugged in. Power's plugged in. It's getting MIDI. Why aren't we outputting MIDI? What the F? Why would you not output MIDI? What's your deal? What? Did I change channels or something? 8. What octave are we on? We're on 4. C4. Unplug it. Plug it back in. Did I unseat one of the wires on it? Okay, let's check this one over then. Power back off. This is why we test like this. You guys are wondering, like, man, why did bother hook up the oscilloscope to that channel to the very first step? Because we know that works. We've been using it all day. Yeah, that's why I did it. That's why I did what I did. Let's get this thing back out. Why he do like that? Call it experience. Ain't nothing work. Nothing ever works. It sucks. Just can't win. Double check with this thing that all those MIDI wires are connected. They look connected. I mean, the MIDI LED was flashing, and we've got this thing plugged in properly. We're not in a programming mode. Everybody's plugged in the way they should be. Let's try turning it on again and seeing if it works when it's outside of the shell for some reason. That was weird. Why didn't it do anything? Plug that in. It might be the settings on the M audio changed when I was moving it around. But this is the yellow trace. We'll put it in this gate, turn this thing on, give it a MIDI. Nothing. Try the mod. Why were there so big spikes there? And why aren't you powering fully? Is there something wrong with my power? No, we've got all of our LED. The plus and minus 12 volts are functioning. Yeah. This should be C4, so we should be somewhere around 4 volts with it. And this is on channel 1, so the yellow trace should be where we've got 4 volts on the scope. And my LEDs aren't turning on either. Turn the slew rate? No. Why would it work on the other one and not this one? What's going on here? That speaks to me of something not being at the right voltage level. But I have a feeling if I take a multimeter to the thing, it'll just say that it'll be plus and minus 12 volts. Let's just double check. I got a bad power cable, maybe? Give me the probes! There they are. Set you on volts. Look at this. Negative 12. And then up here, positive 12. Okay, so my volts are perfect. I am perfect in every way. I mean, with the LED flashing, that means the microcontroller works, so why isn't it outputting anything if we're on C4? Strange issue. What the... plugged in back here? Yeah, plugged in back here. This guy's plugged in. Program... What about... Channel assign? Let's see... Channel assign, it says 8. Channel assign 0, enter. Okay. I'm getting MIDI messages. And channel assign 1, enter. Still no output. Octave is C4. Channel assigned back to 0. That should be the one that gets it to output. Is there something broken between my tester and this thing? Because those voltages were correct. If the voltages were wrong in my other thing, could that be affecting it? That's a scary thought. That's a scary thought. Perhaps I built this stuff so wrong that it only works with reversed voltage. That doesn't make any sense. Oh, bother. That doesn't make any sense. You have 1, 2... Oh, I didn't power up the VCO. I don't have a power cable for it. Let's get a power cable for the VCO at least. While I'm distracted, I'm thinking about this problem. I ran out of long power cables. Oh no. Need another one. Let me go get one. One sec. Why wouldn't it work? These over here. I got plenty of parts and stuff. Huh. Try the other channel of this thing. Well, no, because the LEDs on the front would be lighting up. That's the problem. The LEDs on the front would be lighting up. And I know this thing is getting plus minus 12 volts, and I know it's getting MIDI because the LED is blinking, which means that we're probably on the wrong, like, channel. It's probably on the wrong channel or something where it can't understand what it's getting. Let me just turn this off real quick and find, by feel, find where the power plug is for the VCO. Up to the right, I can feel it right there. That faces that way. What is in the way? Oh, the BCM15 has a big circuit board sticking up in the back. All right, so I'm being lazy here, and I'm going back behind the thing in order to plug in the power. And I'm looking for that gap. Oh, the gap is facing this way, so I need to flip the IDC cable and align it. And it's got a shroud around it, so there's only one way that it'll plug in. And then that goes to here. And we measured the power. Power output is at plus minus 12 volts. This will make it harder to plug in more stuff. I mean, I guess I can move these all over and stagger them like every other, one for top row, the next for the bottom. So if I have a module in the top row, put this here, and the next one here. Yeah, there's plenty of room. Okay, yeah, that spaces them out nicely. And then all the bottom row ones will go in the second, third, the second, fourth, sixth, etc. Okay, so back to step one, which for some reason we're messing up. Story of my life. Turn this thing on. I hit notes, I see this thing flashing, but nothing is happening up top. What did I press on this thing that messed it all up? Channel 1? Oh, there it is. Yeah, wrong channel. So now we're on channel 1, and we actually have outputs from this thing. I must have hit the plus and the minus button when we were futzing around with everything. So let's put the screws back in the module. A little troubleshooting there. Why does my thing not output? Is the power bad? Nope, power's not bad. Is the MIDI connector not plugged in? Nope, it's plugged in. Is the thing creating the MIDI signal? Well, the LED's blinking, so there's a lot of stuff going. A lot of stuff has to go right for that LED to blink. So, is it the MIDI message? And it turns out it was. We can wedge this thing back in. That power plug is in an irresponsible spot where it's kind of putting pressure on this module, forcing it upwards. You really want to clear that power plug a little bit better, and some of these module makers don't do that. They put the power plug at the absolute maximum edge, and then that makes it hard for this to put it in. Buy it a drink first, might put out then. Ugh. Hey, I'd rather have sober consent from my modules, okay? Okay, so test the output. Mod, which is the velocity, low, tiny, big velocity, varying different kinds of velocity. Cool, okay, there's our velocities. Perfect. Node per volt. This node, this node, this node, this node. There you go, C4, burp, 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 burp. Cool, okay, that works. And then gate. Note goes down, note goes up, note goes down, note goes up, note goes down really hard, note goes up, down, up, down, up. Okay, cool. there are our outputs that we will synthesize with. So let's start with the ADSR. And the ADSR output we'll put on this channel just so that we can see what it's doing. And we're going to take our velocity. Hold on. That one actually should probably go into the VCA. So the volt per note there. This one is a gate. Gate goes into here. I guess the velocity for the trigger. Yeah, I guess that's the way we're going to do it. I might split that signal up and put it into another VCA, and that way we can have the piano key. Actually, that does respond to the velocity. Okay. Yeah, that does. Oh, cool. That's really nice. So the harder I hit it, the harder hitting it is. When we get up to 5 volts, then it goes down and sustains, and then it decays. Cool. Very cool. Okay, so that's ADSR. ADSR then goes into our BCM15. What are the ins and outs of the BCM15? Let's look that up real quick. VCO. VCOI? No. Really? BMC. Voltage controlled amplifier mixer. So in, CV, out. Easy peasy lemon squeezy. So in, coming from there, CV we'll put here. Input, we will take the sine wave output of the VCO and go into this input. And then the output we can put into the attenuator. And then we can observe it on the blue channel, which we'll zoom in on a little bit. And so if I hit a button, absolutely nothing happens. Let's turn this all the way up. I see a little bit of something going on there. Turn this up. Why is it still outputting? Whoa. And then there's our waveform going through the ADSR. And the higher I go, the higher frequency it is. We can jump up a couple octaves. There's super high frequency, go down a couple octaves. We're in octave 1. Those do not look like the wave is actually changing all that much. Where are we getting our... Oh, I didn't hook up the volt per note. So let's do that. Let's just put this on this long... well, I want a shorter cable. I didn't hook up the notes yet. It doesn't know what note to play. It's just playing whatever default idling note it has. So we do note per volt and put that into the CV input. So now I hit a note, and as I move up, move down, it gets higher and lower. You can see the waveform is more compressed depending on where I am on the keyboard. What does this sound like? Dick. Let's get it hooked up. So I get the speakers, plug them in. A cool looking waveform. Yeah. I appreciate the synthesizer stuff being explained in these terms a little bit more clearly. It helps me get my bearings and figure out what the heck is going on with this stuff. Julian tried to explain it to me a couple times and it didn't really click. 60 hertz feedback. I need my little stereo converter here. I have a mono to stereo, which is this little guy, and stereo in here, and then mono into the other side. We'll put that in here. I hear nothing. I should be hearing everything. All right, I'm not getting any audio output. Let's try plugging in the speakers directly into here. Oh, I can hear something. There we go. So why are we sustained? Oh, wow, turn it way down. This thing isn't letting go. Cool. All right, you guys may not be able to hear it, and for some reason there's a droning happening here. Let's turn this way up so you guys can hear. Cool. I don't know what all that noise is, though. What's going on with that? Why are you so noisy? It's like this is always letting something through. I think it has to do with the ADSR, though. Yeah, there's the release. So when I hit the button... Can you guys hear that? Can you guys hear the music that's going on, or the notes that are happening? Something isn't cutting off properly. I kind of want to split the output of this thing. Is this one cleaner? That one is a little cleaner. My attenuator might be the fault. No, it's just not, because it's like much less volume from this. Let's go to one of these and then go to this. And then we'll hook up the output of this to there. I need a shorter cable. Shorter cable. There's like a droning that's going on, and I don't know what the problem with that is. You can hear the noise. Good, 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 good. Good, 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 good. Good, 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 good. Das ist gut. Oh, I see. That was touching a power pin. There, now you can see what's outputting. See, it's like this signal is blasting through everybody. Well, now that's just silent. That could be a problem with this board, actually. I don't think I've fully gone through all the steps with this VCA to get it all hooked up. That's much louder. So either the ADSR isn't cutting off. Did I do like the wrong... Flip these two maybe? Nope. Flipping back, flipping back. That's a release. This would be sustain. Turn down attack. Yeah, that fades it in. Go down an octave. Wait, is this below where this thing is? That's the wrong note. Go up. Okay, making supple, soft noises. This isn't cutting off, so I think this needs to be adjusted. Let's try the channel below this and see how that reacts. Same thing. I think those potentiometers on the other side of this board, I think I need to adjust them a little bit. Let me zoom in on this. Why is it so noisy? I guess because it's always outputting something. Yeah, and we're not triggered on that channel. So let's go back to triggering on this channel. Trying to hit the X. Please. Just hit the trigger over here. That's like leakage. Let's attack. Faster. Okay, so it's making synthesizer noises, but it's also reacting kind of like a hurdy-gurdy, where I can't stop the droning going on. And I think it has to do with adjustments on the BCM15. So I may take it out and mess with it. Now, sometimes it hits hard. Yeah, I think it has to do with BCM15. We got to look up how to adjust BCM15. I want to change the nature of the sound that I'm hearing. That one needs more controls to work. Oh, welcome to early computing. Whew, that is inconsistent. All right, get out of there. It sounds like a common synthesizer preset. All right, let's get the BCM15 sort of loosened up here, and then I'll be able to get to the potentiometers and adjust this thing a little bit. So screwdriver, it's over here. Yeah. So we made a very basic synthesizer. This is like the beginning of everything. The BCM15, given a slightly better tune, will be able to actually do its job and cut things off. The other question is, are we providing the BCM15 with an actual cutoff voltage, or is the ADSR sustaining a voltage level? And maybe we should test that. This is like the most basic of your analog synthesizer setups. Pretty cool. Yeah, let's just take a look at what we are giving our buddy over here. Oh, that's not good. Why is there a 1.0 volt signal present? And why does it vary when I hit different keys? I mean, that should be the attack, and then it comes back from the attack, and it should be at 0 volts. So is that the MIDI thing, or is that... Let's test the other channel of the MIDI thing. No, it's still 1 volt return. Okay, so what are you? You're at a volt. No, you're at 0. Okay, so it's the ADSR that's doing it. Unless you are culpable. You represent 1 node per volt. That was the wrong one. Looked at the wrong one. Let's see what you're sitting at. Yeah, you're sitting at 0. Okay, so it's not the MIDI thing. It is the ADSR. With nothing hooked up to the ADSR, you're stuck at a volt. Why are you stuck at a volt? Okay, that's the one. That's the culprit. We now do research. It's not the BCM, it's the ADSR that's doing it. I think I adjusted the BCM. I think I did go through that procedure. It was kind of annoying. I had to just make sure that a full volume waveform didn't cut off in either direction. Loud or soft. Okay. So the BCM 15 is a little bit more punk rock. Somebody took one of those copper-clad boards and just made it, which I'm all for. That's totally awesome that they did. DIP package LM137s replaced with SMD. Oh, I have the DIP package one. 4 simple VCA circuits run into a summoning mixer. No, wait, that's the wrong one. We're actually this guy over here. No, not you, not you, not you. No. Here we are. So nonlinear circuits ADSR 312. 312 envelope generator. It's very capable, easy to use, and discrete. No CMOS or op amps. ADSR with a retrigger function for more complex envelopes. Okay. There they show it going all the way down below. I believe that's 1 volt. Maybe that's actually how they build it, so that it outputs 1 volt constantly. That's very annoying because that means I have to adjust the next thing in line. What's the difference between chaos and randomness? That's not what I'm looking for. Build guide. Aries 312 ADSR, originally sold as a kit in 1975. Design does not use CMOS or microprocessor. Instead, it is discrete, meaning all transistors, diodes, and passive components. This is common in the 60s, became rare and rarer as op amps became cheaper. ADSR stands for Attack, Decay, Sustain, Release. For a full description, an extra feature of this module is the separate trigger and gate inputs. The envelope will remain in the ADS stages while the gate is high and enter release when the gate stops. We saw that, and it seems to be working well enough. The trigger input allows you to re-trigger the envelope while in the ADS stages. This allows you to set up complex envelopes, which can be very interesting and allow your sounds to move away from the standard musical paradigms. For most WAMOD systems, the LFO square waves will be ideal for running the ADSR. Okay. In June, wait, what? We will build sequencers which have a variety of gate inputs, blah, 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 blah. There are 5 1206 size 100K surface mount SMD resistors to install. Oh, okay. Do these first. Either way, put a little bit of solder on one pad. Oh, so they are embracing surface mount. I thought I was putting surface mount on through holes. 2 different types of transistor. BC547 marked as N as an N channel. N channel doped. And BC557 marked P. It's important not to mix these up. Oh, yes, it is very important. The marking of the PCB, blah, 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 blah. Yeah, I don't like the way. So the one thing that I'd argue with nonlinear circuits is their usage of actual marking of what's on the PCB. That may seem like the most straightforward way for a beginner. You say, where is the 4K resistor? Why don't they just put a label? Why don't they just put a label there that says 4K? The reason is that values sometimes change depending on either supply or revision. If you suddenly want to change your resistor to a different value because maybe you've tuned it a little bit, or experientially you've learned that something operates a little differently, or maybe you made a mistake, you can say C4 in your parts table is now this different value. You don't have to go in and say, hey, this 100K resistor that's in this location on the board needs to be changed out. That you don't need to do that kind of a revision. You just change it in the table and you're done. It's so much better to do it that way, but they decided to do labels directly. Advice on how to solder, blah, blah, blah. Nothing about like adjustment. There's no adjustment, it seems, on this thing. Why is there a volt getting through? Could it be some of my stuff? Does it need some kind of an extra attenuator to make 1 volt into 0 volts? They show the ADSR plot right here, which is very good looking. It looks like an ADSR. Looks kind of like what we achieved, except theirs drops down and this says 1 right here. So that 1 volt might actually be a feature. ADSR 312, non-linear, 1 volt. Build notes. Massachusetts-based synth manufacturer in the 1970s, early 80s, had produced many of their modules in kit form. You get the ADSR3, whatever. There are no CMOS chips, 100K, blah, blah, blah. Solder all the things down. They've got a precision capacitor on that one. I wonder. This precision cap. Do I have one of those? I don't. I can't see the back of the board right now. Yes, I followed all these steps to the T. No comments about it. Yeah, I'm just wondering because it, like, isn't hitting 0 volts where nothing will happen. Magpie Modular. Of course, you know, they have a problem with it, and it's nothing that anyone's ever talked about before. Welcome to modular synthesizers. You'll find problems with these things that no one else on the planet has come up with. But again, I said it before, I mean it. This is my happy place. I like doing this stuff with synthesizers. It's more hands-on and... Oh, this is an ad. All right, thank you. Maybe there's some explanation in here, I don't know. Oh, this looks like it's using the CM3340. Because I can make waveforms that look like that with the CM3340. He's not doing anything with AEs. This is a disaster. This is completely the wrong thing. VCO demo. Envelope generator DUI ASR projects from Modular Addict. Maybe there's some information in here. I've clicked. Please load the page. Why is page loading so slow these days? Maybe it's just me. Maybe because I'm streaming. Ugh, there we go. Oh no, this is where I bought it from. This is where I bought the kit from. Modular Addicts. Let's get out of here. I have no way to figure out why this thing is giving me 1 volt. New Chrome. Oh, maybe that's why it's so slow. I need to move to Firefox. This is enough. Enough with the ads. Ads are just cancer. All right. So we're looking at the ADSR. I've got the old one here. It's the same circuit. This one is slightly differently adapted. I need to tilt the page and actually get into the circuit now and see what's happening here. Holy hell. What can I do to this in order to adjust it so that it drops that 1 volt output? I don't think it's sustained, but it's when it's released. So you got the 2 outs there with the 1 kilo ohm resistors, and then we have the LED to ground, and then this is being switched positive or negative. That one goes to Y plus, and there's a diode across it, and there's another diode there that leads to, holy hell, that junction over there, is that my release? So gate and trigger. Trigger would be a pulse. Instead, we're giving it a voltage level. What are we giving trigger? Oh, I don't have it hooked up. Trigger was being given... Yeah, gate gets the key press, and then trigger gets the voltage level. And it probably intends for trigger to be a quick signal, but as long as we are hitting the key... Oh, is this thing powered on? Yeah, it is. Okay. As long as we're hitting the key, what's happening? Oh no, but that's not, it's not due to an external signal, because I mean, look, it's at, you can't see the, let's go back to here. You can see it's not hooked up to anything, and it's giving me this 1 volt signal. That's what's keeping that droning going on. I need that to cut off. If I had some other kind of like a control voltage attenuator, I mean, I could put it through that. That would help. But I think just fixing this is probably going to be, there's probably something wrong with it, and that's why it's doing that. If I adjust ADS and R, nothing is going on. Okay. ADS and R, nothing is going on. What about this output? Just a little 1 volt. How about the inputs? There's nothing coming back on the inputs. Those are... Ugh. Okay. 1 volt coming out through this whole system. Need to write up on a theory of operation for this thing to quickly diagnose any issues. Because how does... the thing that I want to know is the mechanism that returns it back to nothing. It's got to return back to nothing. Holy heck. Could be the 2.2 microfarad, isn't... I don't think that's the case. It's not sensitive enough that just touching it returns it back. This is... So the ADSR is a fundamental component in the creation of the noise that this thing is creating, that this thing is outputting. And so without that working properly, and I was hoping that it was working properly, we get sort of a hurdy-gurdy effect. A hurdy-gurdy is an instrument that has a spinning drum that plays the strings of a thing that you hit buttons on in order to activate the different strings. And so you get while the thing is operating, and it's always the same note, which makes this really cool note dynamic. It makes a really cool, like, you know, return note scheme of the songs that it plays. You can also play chords with it, so the analogy kind of falls apart. We're not always returning to the same note. We are returning, actually we are, wait a minute, we are. We're always returning to 1 volt. So that's our hurdy-gurdy in this case. I didn't sign up for a hurdy-gurdy though. I need this thing to return to nothing. Ladies and gentlemen, here's the reason why. This is why when you're creating a schematic, you never ever ever do 4-way junctions. This is my own personal rule. It is something that I prefer very strongly. It's not something you guys necessarily have to adhere to, but it does avoid the situation where if you see a 4-way junction and there's no dot, is it connected? In the case of any schematic that I make ever, if you see a 4-way junction without a dot, that means that it is not connected, because I will not allow more than 3 things to connect on a line. That way, if you have something crossing over, you know that it is isolated. And when you make a mistake and you forget a dot, it's not a huge deal because we know that that's connected. It does not continue on to something else. The cool people have an instrument called the theremin. For those of you who have the lowest amount of awareness of instruments, the theremin... Hold on, I'm going to cough. A theremin is a tool, it's an RF instrument, it's a radio instrument. It uses radio waves and the manipulation of them in a near field in order to get feedback and change the note. And so what you do is you move your hand over and up against 2 different antennae in order to play a note that sounds like the Doctor Who intro. It's just that kind of thing. It has a little bit of vibrato and it has like a note thing. It's a fun little instrument. I should get one, but I can't afford one. I could probably make one with a couple transistors. I can't make heads or tails of this fucking thing. Okay, so we get a gate. I think the origin of this is that it's not precisely a gate signal. We don't have a gate precisely. Or no, rather the trigger, rather. It's not a precise trigger signal that we're giving it. No, but wait, we're not. I unhooked everything. Wait, with everything unhooked, it still is outputting 1 volt. So we're isolating that out with a 100K. So very little current goes through that. Q10 would be possible to remain triggered, although we're not seeing any kind of a depreciation of that 1 volt. It's just stuck there. Oh, because I don't have any inputs on it either. But still, it's just stuck there. Where's channel 2? Bring me channel 2. Yeah, so mod goes to 0. So that works as a trigger because it goes back to 0 whenever we activate it. So let's put that into trigger. Where'd my wires go? Yeah, so we activate the ADSR and then it comes back down and it's at almost a volt, which is enough that the BMC15 allows audio through. $35 for an AliExpress theremin. It's a little bit loud. So that's with only so if I add this one to it, that'll add an extra gate. Interesting. Wait, do I not even need that? Could I do it off of... Wait, did that change the note? Okay. Slew rate is fun. Let's turn slew rate back down because we're not doing that kind of testing. So I don't know, these two working together is a little weird. If I just rely on ADSR instead of the velocity that I hit the key at, yeah, and now it hits the same every single time, no matter how hard I hit the key, which is, you know, less dynamic for your piano player. It's less dynamo for your piano pairs. Oh, pitch bend works. But that 1 volt drone is very annoying. Is there like a diode that I could put in this? Not understanding how the circuit works, it's a whole bunch of transistor circuits working as like amplifiers and stuff, and there are different stages to the whole thing. So you attack, you sustain, you decay, you release. Those are all separate functions, and not new tab, you stupid mouse. They all do things differently for different stages, and it's all very base level transistor stuff. Can we find something about this drone is killing me and I'm about to like slam an axe into my own synthesizer? If I could find a circuit theory on the AR312. No, I can't. Air 312 operation. Oh, it's terrible. Turn that way down. Go down an octave. Uh-oh, something's wrong with the way I program this thing. Because we're at octave 0, all the notes should be distinct. But they... That's fine. That's C0. C-1. Yeah, I don't get anything below that. It's always going to be the same. Oh, and we're in a different waveform. Hold on. Back to sine wave. Much softer. Ow. I hate you, triangle wave. Ugh. Why is it... Oh, it's so loud. If I turn it down, maybe the drone won't be as bad. Not really. Oh my god. This sounds like an Amiga is making these sounds, and I don't like it. Nasty. Oh, there's some cool stuff happening in the background. Yeah. Yeah, you can make some cool noises out of this thing, but I'm starting to reconsider whether or not I want C0 to be, you know, if I want to be able to go deeper than this with the bass. But maybe I'll need to configure a different VCO to go more bassy. Also, I think the tune is off by a little bit. I need to put a tuner on this thing. The biggest problem, though, that I'm having is this drone. 1 volt is getting through the ADSR and ruining my day. And so it could be that something is not exactly soldered correctly, but I have not been able to find... Wait a minute. This looks like a very old document indeed. Aries module AR312 envelope generator. We've got all our stuff. Written general guide to familiarize the builder with components. So that's all how to solder. Run a wire connecting the 4 jacks labeled patch on the front panel, etc., etc. Excuse me. Arrows indicate the direction. Give me a little bit about how to tune it. No trim or calibration, but you should perform an initial test to ascertain everything is functioning properly. What do you think I'm doing right now? Why are you telling me what I'm already doing? Jeez, rude. Rude. Getting used to the scene buttons. You perform initial blah, blah, blah. You may use a DC coupled oscilloscope or voltage control device such as VCO, VCA. Blah, 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 blah. In order to test the gate and trigger inputs, you will need a gate and trigger such as derived from an AR313 keyboard. We've kind of got something like that. It's not available to test. It can be performed at a later time. Proceed with the follow. Proceed. With the power supply off, connect the 15 blah, blah, blah. 15 volts to pin 3, ground to pin 1. We're 12 volts, but that's okay. Double check these connections. Oh, yes, double check these. That step right there, that's in all caps and underlined, and probably like underlined with blood, is something that my friends could really learn a little bit about. Output of your envelope generated to the oscilloscope or voltage control device. Turn the attack, decay, and release pot fully counterclockwise. Okay. Yoink. Hold on. Yoink. 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 And then our... Yeah, we're outputting to that channel, and then I want my attack generator, put that on the velocity one. We'll zoom out on the scope a little bit. So this is with the absolute maximum, and it's just creating a little blip. Let's turn the trigger up on this thing. What are we triggering on? On channel 2. I've got the trigger right there. There we go. There it is. Okay. Oh yeah, you guys can't see the scope. Let's bring the scope back. Let's see. Boop. And oops. Hold on. Put that one back. Frame the scope. Try to read towards the middle of the page. Okay, so there's that. Try to get a better angle on everything so you guys can see everything that I'm doing, because it's the minimum requirement for streaming. Yeah, sometimes the trigger isn't catching the thing. Man, that drone is very annoying. I'll turn that down. Fully counterclockwise, and the sustain pot, ADS, fully clockwise. Depress the manual gate switch. There he is. Observe a square wave of 10 volts at the output. You know, we're kind of around 6 volts. We're kind of settling in on 6. That was maybe 7. I think that's affected by the signal that I'm giving it. So I'm going to get rid of the mod. There we go. Wait a minute. Let's zoom out. Actually, let's move this down. Okay, so there's 10 volts, and so boop. We're getting around 8 volts. That might be because we switched from 15 to 12. Press manual gate switch, observe a square wave of 10 volts at the output. While depressing the manual gate switch, turn the sustain pot counterclockwise. The output should drop as you turn the pot. Certainly does. So I'll sustain at 4 volts, okay. But we're still not dropping down to 0 volts, which is the problem. Did you just start your journey into modular? Yeah, I just started 2 years ago. I've been building these for a long time. This is the most basic setup. I just got the MIDI to CV converter, the Erica Synths one. It's all tuned up and everything now. I learned how to tune it. I had to hit a button on the keyboard 75,000 times. I probably should have done a sunk cost fallacy and made an Arduino program that would output the key press 10 million times. That would have been a much better use of my time. This is the first fully fledged synthesizer, as in having all of the necessary steps in order to make a synth. I realized after building a whole bunch of these different modules, there were little problems with everything, and I had to stop and back it up, come back to the basics, and make sure that every single molecule of the modules that I was building works before moving on to the next one. And so now we have a full, what you would buy if you were if the year was 1972 and you went to the store and you bought a synthesizer, you would get a keyboard that would control some kind of an ADSR and a VCO. It would go into a VCA, get attenuated, and then go out to your other stuff. That's what you would, have. Maybe you'd get a filter, but who knows back then. You probably have to hook it up to a bunch of tin cans in order to get it to sound really, really neat. So this is one full voice from the keyboard synthesizing stuff. And so right now, the problem is the release only releases it down to 1 volt. And so through the speakers, I've got this wonderful hum coming out of the VCO because the VCA is not being tamped all the way down, which is obnoxious. And I'm trying to see what the theory of operation is for the ADSR that I built. It's a nonlinear circuit, and this is the one that it was based off of. This is from the ancient times before, you know, this was written on a typewriter. So now I'm going through the theory of testing on this one. I don't know how that translates to the new one. It depends on what decisions nonlinear circuits made when coming up with the thing. So the output should drop as you turn the pot. That is correct. Turn the pot back to 10. Depress the switch. Attack time should be very short. Why is it peaking? Attack is at none. That's at none. Oh, I see. That was... Okay, so this is sustain. So... little pulses. Then sustain goes all the way up. And we should hold at 10 volts, but we're not. So that's a little something. That could be just a result of going from 15 volts to 10 volts in this design. I feel like that's not quite a C. Kind of sounds like it. All right. While depressing the manual gates... Oh, where are we? Turn the sustain pot counterclockwise. Output should drop as you turn. Yes. Turn the sustain pot to 5. I don't have markings on it. Sustain to 5. So we're going to guess that that's halfway. That'll be about there. Turn the attack pot clockwise and observe the increased attack time. That is increased. And there's less overshoot when it... Okay. That's working. See, look at that overshoot. Holy crap. Depress the switch. Test decay in the same manner. There it is, decaying. Short decay, George decay, short decay, long decay, super long. All right, that works too. Test the release in the same manner. No releasing. Quick release. Sustain, mid-release. Neat. Okay, so this thing seems to be working just fine. Apply external gate and trigger to the input jacks on the front panel. To initiate the envelope generator. What? I did. Observe a waveform at the output. Run a patch cord to one of the jacks labeled patch. Connect the other end to the envelope generator output. I don't have that. The envelope generator is now ready to use. What about if it sits at 1 volt? Wait, don't leave me. Troubleshooting, don't leave me. He left us. He left us here. What happens when my specific problem? Air 312 envelope generator produces a waveform with 4 variable parameters: attack, decay, sustain, and release. Well, this is baby stuff. VCO, VCA, VCF waveform can provide transient information. Envelope generator will initiate upon receipt of a gate trigger and its input. The output will rise to 10 volts and fall from 10 to a selected level decay. Hold that level for the duration with sustain and fall to 0 volts when the gate is removed. Release. Release. The circuit operation is as follows. Okay, so let's get this other schematic. I don't know, we shouldn't trust this one. This is the nonlinear circuits version. We'll have to translate it into that version later. This is the 1975 version. Oh my God, there's so many of the transistors here. Look at them. Oh dear God. Okay, so let me pull this to another screen so that I read it, and we'll look at the circuit as we read it. Make it bigger. Make it big for the old man eyes. Okay, so 4 variable, the envelope generator will initiate upon receipt of a gate. Okay, we already got that. Circuit operation is as follows. Transistors Q1, 2, 3, and 4. Q1, 2, 3, and 4. So that's these 4 along here. 1, 2, 3, and 4. With D1 and D3, so this is D3 right here. D1 is up here. There's a manual trigger button that I don't have. Yeah, I don't have a manual trigger button. But D1 and D3. Let me just double check that we've got the same schematic here. Oh, this page is so slow. Yeah, it's the same schematic. Okay. Yep, cool. Okay. So D1 and D3 are the same thing. Oh, this is great. I love that they have an explanation of the theory of operation and a little testing blurb. Beautiful. It's a beautiful thing. Although we do have to get into the weeds in order to figure out what's going on here. And we'll have to read this while framing it in while keeping in mind the problem that we're having. The problem that we're having is that this thing is sitting at 1 volt. You can see the oscilloscope has it sitting at 1 volt. It should not be doing that. I don't want to have to retune my voltage-controlled amplifier to cater to this specific ADSR. Q1 receives a positive voltage, which is a gate in. So that goes through this big-ass voltage divider, 100 to 1, and then goes into Q1, which is a BCM transistor. At its base, it turns on, and its collector drops to ground. The collector is this one up here, going into a 10K. This thing is being held at positive voltage by a weak 2.2K, is little girly 2.2K. Although 10K is much larger, we are pulling down to ground through Q1 through 10.2 to 12.2 kilo ohms. We're pulling down from positive. That 10K will very weakly pull Q2 down and ground it. And I think that Q2 is a PNP. So turns on its collector, drops to ground. This forward biases Q2. So Q2 is then forward biased. So that current goes down through here and down to the bottom of the circuit. And it also goes down through the whole transistor. And its collector drops to ground, reverse biasing D3. Its collector drops to ground. Do it though? That would drop positive power to ground. That doesn't make any... Oh, Q3. Wait a minute. Q1 receives a positive gate at its base. It turns on its collector and drops to ground, which forward biases Q2. And its collector rises to 15 volts. Q3 is now forward biased. So we're switching. It goes boom, 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 right? This one is pulling to ground. This one is pulling to positive. This one then pulls to ground as a result, because it's the same 100K, 10K. Why we're going through this Darlington-esque array, I have absolutely no clue. That's a very weird thing to do indeed. There are no controls on any of it. But okay, so far so good. We're getting into circuit theory. Turns collector drops to ground. This forward biases Q2. Collector rises 15. Q3 is now forward. Collector drops to ground. Reverse biasing, so D3 is switched to ground. So through the 39 kilo ohm resistor. That's a huge resistor. It's enormous. So it's very, very weakly pulled to positive. It is now being pulled directly to ground, so through the transistor, which has very little resistance. So this will immediately drop to 0, which also drops this to 0, which doesn't do anything. So when this is positive, it's going to put a positive signal here, but when it's negative, nothing gets through because it's a diode. So this has become negative. I am become negative. Q3 bias collector drops to ground, reverse biasing D3. D3 effectively, with D3 effectively an open circuit. So diode, check valve for your current, right? If you think of your current like water. So now all of the current that's sitting in the front of this thing is just not allowed to pass through. This thing is just cut off. If there was positive voltage would be flowing into this part of the circuit with R10, and it would stop here unless it drops to ground. Wait a minute. In which case Q11, go through here, back up to there. It can't go through there. Okay, weird. Open circuit, Q4 is isolated from its positive bias and turns off. Q4 and a positive bias. Where are you getting that from? Possibly on the manual triggering. Looks up down here. Holy hell, this thing is weird. Where are you positive biased from? That doesn't make any sense. Is that coming from over here? I mean, I guess, yeah, that's where it's coming from, the positive bias. And there's the output with D14. What was that? Why did my phone just turn on? My motion alerts. People be doing stuff outside. Dun dun dun. Okay, this is over my head because a lot of stuff is going on in these parts of the circuits that relate to others, and I don't know where the forward bias would be coming from here. Because, I mean, you got the manual trigger over there providing a forward bias. You've got forward bias, I guess, from this going in this direction. I guess that's got to be it. And then this would switch it away. Before the gate was applied, Q4 was on and acted to ground out the incoming triggers. Now trigger entering the base of Q5 will initiate the envelope generator. Jeez. This is a good write-up that I think maybe I need to go over on my own. Oh, here we go. D12 is added to ensure that C6 does not discharge below ground. We're talking about D12 and C6. Could it be down to the diodes that I used? D13, 15, 7, 8, D6. It's this guy over here. Wow, 5 and 6 working together. D12 is added to ensure that C6. Whoops, we're looking for a capacitor. C6. Where are you, C6? I will find you. That's C5. C4. This would be something on the output, I think. There are a lot of diodes. There's C6. C6 doesn't go below ground. That's 2.2 microfarads. Would that somehow be allowing 1 volt to be biased? Unless D11, if R28, which is attack, that shouldn't affect them. Yeah, nothing is affecting. Hey, how's it going? Disco Sundays. Did you get another account banned? What have you been up to? I'm reading the circuit theory behind this ADSR because for the most part we've gotten a synthesizer to work. Right? I can play notes and I can do attack and decay and stuff in order to make the notes act differently. It's kind of cool. But there's like a hurdy-gurdy drone to it. It's always returning back to the same note because for some reason, the ADSR is stuck at 1 volt. That's what we're seeing down here. It's like stuck at a volt. There it is, controlling everything. But as long as it returns to that 1 volt, that means my voltage controlled amplifier doesn't fully cut off the sound. There's always this little drone in the background. It's very strange. So what's going on here? When I press keys on the keyboard, I'm generating MIDI signals. Those MIDI signals go into our little MIDI controller, and they create a couple different signals. One of the signals is a 1 volt per octave signal. So this note and this note are 0.88 volts different, and they go into a VCO. The VCO's only job is when it gets those volt signals in, it'll create the different notes, and it just sustains the note infinitely so that you can put that note into an amplifier. In order to control how that note hits, how it fades in, you use an ADSR, which creates an attack, which is how the slope of the initial note going in, a sustain, which is where does the note settle when I hold it down, a decay, and a return. Is that right? Is that return? Is that the right one? Return is what happens when you release the note. So if I do like a long one, it's sort of like holding down the pedal on the piano. AD. So if I put up a bunch of decay on this, it doesn't hold the note slowly fades downwards in volume. So it's like a resonance kind of, not really resonance, but just sort of like losing energy in the system, which is kind of cool. You can make a lot of cool sounding stuff. You might not be able to hear this very well. I turned it down because hearing all the same notes over and over again is kind of obnoxious. So that's what the voltage controlled amplifier does. The ADSR feeds the VCA and allows it to change the dynamics of the output waveform. The rest of this is either splitting signals between things or attenuating this for the speaker so it doesn't blast our eyeballs out of the back of our head. And that, my friend, is a synthesizer. A synthesizer. A synthesizer. But we're getting noise. That noise is from the VCA. It's from the ADSR, which is not returning to 0. Who are you fixing this for? I'm making it for me. I've been working on this thing for like 2 years, and I've got tons and tons of modules for it. And I realized that I kind of haphazardly went through all the modules and built them. And there are little bits and pieces of every single one that doesn't work. We're running into that right now with this 1 volt sustain that this thing is doing. Why you did this? Why are you sustaining 1 volt on my system? What is your problem? I used a bicolor LED. I wonder if that was what did it. Could that be affecting it? This won't affect my baby. It's so annoying. I'm listening to this note just playing right here. I don't know how musicians are not completely triggered by stuff like this. They just don't care. I guess they've lived with it enough. Oh, they don't even have an LED on this circuit. I see. It might be this 2.2 microfarad capacitor. That could be what's acting up. Maybe there's nothing draining it. I'll have to check the soldering on this whole thing just to get it up and see if get it up, just to get it up, just to see if I can get rid of that sustaining note. It might be, I mean, if I look at the nonlinear circuits version, the nonlinear circuits schematic, didn't we have it up somewhere? It wasn't that window. Oh my God, I'm just listening to this note drone on. I have 1,000 windows open. What more can I say? We're done feeling it. There we go. Okay. So the LED is all the way out here on its own transistor with a 100 kilo ohm. So I actually don't think that would be affected by having a bi-directional. But I don't know why I put a green-red LED in there, because it's not like it can go to ground at all. It can only switch to V+, not V-. Something around this stuff, something's going bad. I'll have to check all my passives. I think we're done. I think I've sort of done the basics of synthesis so that we can have a nice rounded stream. The prospects of fixing this are somewhat weird. I'm gonna have to go through and literally just go over the soldering again. That's pretty much how I see this thing going back together. I will be back on Tuesday. What is that? That's the 6th. Man, this month is flying, which is good because there's a bunch of cool stuff coming out this month and next month. They saved all these things that were delayed for the pandemic, got their like first seasons, and now they. Back in the day, I never had any audio equipment without some DC offset. This shouldn't have a DC offset because this is modular synthesizer equipment. The voltage levels are treated differently, and like 0 is you know, a viable. It should be 0 volts. What is it at right now? It's at, hold on. Let's do a measure on channel 2. That would be V mid, V average on channel 2. So 800 millivolts is not acceptable in a synthesizer because we're talking about pretty sensitive voltage levels. I'll have to also get an app on my phone to tune this thing to see a C note because I don't think this is quite right. Wait. Nope. Oh, it's nasty. It's nasty. I love it. The problem is, I have tuned this thing to go very high. We are only at octave 3. I can go all the way up to 5. I'm starting to reevaluate my volt per note scheme here. This is about as low as I go. Oh. Yeah, I should make this go lower. Play Freebird. I don't know how. Ew. I don't know what that is. It's just like an element of noise in this in the signal when I touch that adjustment. Ugh. See what the output waveform looks like. That would be here. Actually, that's attenuated. Let's get it before attenuation, which is output from this thing here. Juice that all the way up. Oh, my voltage is too high. Channel 1. Get down to... Huh, why am I not getting anything output there? Something broken. Oh no, that's supposed to be... Yeah, it's supposed to be the output of that. That should be a huge signal. Huh, something ain't right. Something ain't right there. Oh, that just cuts us off. What the heck? That gives it all that noise. I guess that's the PWM signal. But where's my ADSR? What the heck? Oh, because that's just the passive signal. Yeah, there's the full signal. Craziness. All right, well, everything's still broken. Although we've gotten a little bit closer to the thing working, it's still kind of broken. I've got it working as a very basic single voice synthesizer, your most basic synth, which is, it's an achievement. You know, I got some done. I'm going to have to go over the soldering, and then I'm going to have to see about the voltage controlled amplifier tuning. I don't think within the whole paradigm of the operation of a modular synthesizer, 700 millivolts is a significant amount of power going into a VCA. I think 700 millivolts is doing what it should do. It should not be coming out of the ADSR. I know 700 millivolts is nothing, don't worry about it. No, that's not how we do with modular synthesizers. That thing needs to be at 0 volts because I have fully let off of everything and it just goes back down to nothing. When we unplug everything from the ADSR, it sits at 700 millivolts. So I feel as though you have more stuff in that place since I was last here. It tends to kind of pile up, and I go on sprees of cleaning, and then it sort of reduces a little bit, but I have done some massive amounts of cleaning, and it's still a big pile of crap. So our other notes then offset by that voltage. This is going into the voltage controlled amplifier, and the voltage controlled amplifier basically is a voltage controlled volume knob on my signal. And so if there's 700 millivolts going in, it thinks the volume knob is turned up just a little bit. I don't think the VCA goes into the negative voltages. I don't think it's allowed to do that. Mostly just audio goes into negative voltages, but we're dealing with a voltage that would be like from 0 to 5 volts, 0 to 8 volts maybe, telling it to turn the volume all the way up to 11, depending on the signal that I send it. So the ADSR, attack, sustain, decay, release, that is creating that voltage signal that will move the volume knob in order to give us what sounds like somebody playing a key on a keyboard or plucking a guitar string, virtually making that signal, right? That the way the attack comes in, the way it sustains, and the way it releases, that'll shape that audio using the amplifier in that way. So when we look at it on the oscilloscope, it's just basically telling us the position of the volume knob over time. And so those quick changes can affect how your thing sounds. The reason it sounds like a hurdy-gurdy right now is because it's not returning all the way back to 0 volts, which would cut off the audio. Instead, it's returning to 700 millivolts, and if your range is only 5, that's almost a fifth of your volume knob that it's not utilizing. So it will go all the way back down to 1/5 of the whole volume knob travel, almost a little bit less than that. But still, it's like that's enough that you should start hearing something out of your audio output. So it's unacceptable that this thing is operating that way. We went through the theory of operation of that circuit. The only way that I'm going to be able to peel out how the hell this thing is sustaining itself at 1 volt is by looking through the circuit and seeing what is affecting my baby. And this, shouldn't affect my baby. And then my baby is sustained at 1 volt. It makes no sense. It will make sense the more I read up about it, but it seems like I got to sit down with the 1970s literature, get to know it, and then look at the modern circuit and see if there's something weird going on. Or I can take a pot shot and just go through it with the soldering iron, make sure that everybody's soldered, because if you might cut off one of the things that's supposed to pull it all the way back down to ground, or maybe the capacitor's not there, something weird like that might be going on. And killing my synthesizer. So as we move along with synthesizer stuff, we will expand and we will figure out more weird things like modules that we can play with and just get this project moving forward, because enough is enough. It's been 2 years since I've been able to actually make stuff that sounds like notes. We finally have it. I also have a VCO that does chords that we could build up at some point, because chords would be a lot more fun. But anyway, until then, you guys, oh my God, I would say go touch grass, but we had a politician say that, so now I have to figure out what the fuck I'm supposed to tell you guys now, because the lid has been blown off of all of the phrases that I use. It's absolutely comedic that would happen. Freaking governor said that. He said touch grass, so we can't say that anymore. I'm sorry. Those are the rules. I guess you guys go out and be prolific and do cool stuff and share it with me on Discord, because that's what I love. I love looking at the cool stuff that you guys do. Even if I don't get a chance to react to it, I try to react to most of the stuff to say that, yeah, I saw that, that's cool. I would love it if you guys would share some of the weird parts of your life on Discord. The link is in this one. I know he completely just took the wind out of the sails. But we're going to be back in exactly 3 days, maybe 18 or 16 hours, maybe 54 minutes and 3 seconds. Actually, wait, that calculates it to 12:35. So yeah, it's 3 days, 19 hours, 54 minutes and 3 seconds. And dwindling. The time is dwindling until I come back steadily. Remember, for every minute that passes for you guys, it's been 60 seconds for me. You just keep that in mind and you'll know sort of what's going on. No, thank you for attending my stream. I appreciate all of you guys. I am going to create more enemies by not raiding anybody. I will create more enemies. All the usual players are around. Davey's doing My Summer Car. Deadlock. Garrick Durak is on. If you guys speak the language, I forget which language Garrick Durak is. Yeah, thanks for hanging out at what, 4 o'clock in the morning for you. Appreciate it. That's my cousin from oh, it's not Perth, is it? Is it Perth? I don't know Australian cities, and I keep forgetting. I keep asking, and I keep forgetting where he's from. What city? Oh, I'm so bad. I'm so freaking American. It sucks. Brisbane. That's right. 6:42 a.m. Go get a cup of coffee. All right. I'll catch you guys later. Love y'all. Catch you on the flip side. I'm trying out new phrases until one of them sticks. Goodbye. That's not a good one.